also handling number of projects of NITR. And I just hand over the session to Dr. S. Chatterjee. He will be giving you an overview of all the renewable energy sources, mainly the hydro and the wind power system and the hybrid systems. Thank you.
Thank you, Shimi. Good morning, viewers, participants at different remote centers, and my own participants here. I wish you a very good morning. Good morning. To start with the session, what Shimi has given me, Dr. Shimi, she has assigned me a task to talk to you about some renewable sources. Of course, renewable sources doesn't necessarily include hydro, but I say that that's also a renewable source, because hydro has become so popular in our country or in any part of the world that it is no more a renewable source. But definitely water is a renewable source. So I can call it very safely, you can also call it safely, that hydro generation is also a kind of renewable generation. Someone has to operate it, I think. तो पानी मंगवा लेना थोड़ा रब कर देंगे क्या पानी पानी दे देना पहले इसको ऑन करो ओपन करो अच्छा ओपन करना राइट देन टिक टिक तो करना है ना मेरे को थोड़ा सा अच्छा नहीं लगता मैंने yes so my task is to discuss about hydro and wind generation. Now if I talk of hydro first, bulk of it, as I said in the previous class also, I told you that about 65 to 67% of our total generation is through coal-fed thermal power generation, and rest total about 35% is left, out of which about 20 to 25% is hydro. So the bulk generations are thermal, which is about 65%. Hydro is about 20 to 25%, and rest has all kinds of generation processes, that is nuclear and other non-conventional power generation. So the bulk is thermal and next bulk is hydro. So this is a very, very important aspect of generation of power in India. And if you say the hydro, there are two kinds of hydro. One is the main hydro, and second is small hydro. Now what do you mean by main hydro, small hydro?
Main hydro is base load or large generation.
Exactly.
Generate
Exactly.
megawatts more than that.
Yeah. It is the large generation, the bulk generation through hydropower, through hydro as source is known as main hydro generation. And some of it is also generated by small amount of, hydropower, that is known as small hydro. It can further be classified into mini, micro, pico, etc. depending on the size of the hydropower station. Now, it is very obvious when we call this hydro generation, the turbine of a thermal power generation and the turbine of a hydropower generation will be different. Now, can you tell me, by looking at the machine, when you have to generate power, means you have a prime mover and you have an alternator, is it not? The basic principle is that through a prime mover you give rotational power or a potential to the turbine, and the turbine is then coupled with the generator alternator, it produces electrical power. That is the basic principle. So you need a prime mover and an alternator. The prime mover is basically known as turbine. So when you have a turbine and an alternator, the coupled system is known as turbo alternator. Turbo alternator unit, या इसको machine भी बोल देते हैं. So turbo alternator machine or turbo alternator unit is the main heart of the system, which feeds the mechanical power to the turbine, to the alternator through turbine, and the alternator produces electrical output. Now the question is, if there are two types of generations, as I said, thermal and hydro, these are the main, of course. So the machines will be same, the principle will be same, but they are different in configuration, they are different in shape, they are different in operation, etc., etc. Can anybody tell me what is the basic difference of a thermal machine and a hydro machine? Can you tell me? Suppose I have shown you one machine is this, is say A, and is B. You have got A, you have got B. One is a machine or a turbo alternator unit meant for hydropower generation. Another is a machine which is meant for thermal power generation. A is the machine which is meant for thermal power generation. B is the machine which is meant for hydropower generation. Can you, looking into it physically, tell that this is a thermal power machine and this is a hydropower machine? Distinguish between A and B. A goes for thermal, B goes for hydro. They are definitely different machines. Principally, they are acting the same way. But what is the physical difference or the structural difference between the two?
Hydro machines are smaller as compared to thermal machines.
Smaller.
Speed is large.
Hydro machines are run by a water surge system.
Run by is an. I am just saying that if you see the construct by look, physical look, A is there, B is there. Can you say that A is a thermal machine, B is a hydropower machine?
By looking at turbines.
By looking at the unit, I am saying. Have you seen a thermal power generator?
No.
So that is the problem. You must visit, go to a thermal power generation and see what is the unit. As I am saying, turbo alternator unit or turbo alternator machine or turbo alternator set. There is a turbine which is coupled with a three-phase alternator. That becomes a turbo alternator machine or a unit. Similarly, go to a hydropower generation, you will find that there is a turbine which has been coupled with an alternator there also, and this is the three-phase alternator, and that becomes a turbo alternator unit for hydropower. Now, let me tell you that you can distinguish between the two by seeing it. Physical construction. One is known as a horizontal machine, and the other is known as a vertical machine. Which is horizontal? Tell me. A is a horizontal, which is meant for thermal, or B is a horizontal?
A is horizontal.
Why?
Hydro turbines are rotated like in vertical direction.
No, it's not that. It's not that. It is the question of a salient force machine and non-salient force machine. One, as he has pointed out clearly, that one machine is at a higher speed, much higher speed. The steam turbine, we call it steam turbine, and the water turbine or hydro turbine. This is steam turbine. The turbine which is used for generation of thermal power generation is known as steam turbine. And the one which is used for hydro is known as water turbine. Now, it is obvious that steam turbine will be much higher speed machine. It is a much higher speed machine, and that has to feed mechanical power to the alternator, that is AC generator of thermal power generation. तो उसमें जो है speed कितनी होती है? Synchronous machine की speed, how much is the synchronous machine speed depending on the number of poles? So what is the maximum speed of a synchronous machine?
3000.
It is 3000 RPM. So here it is 3000 resolutions per minute, and here it is much lesser, 600 RPM, 700 RPM, or at the most 800, say 500 to 800 RPM. There are different types of turbines, such as Kaplan turbine, etc., etc., which are much lower speed machines, and they, when have to be coupled with a machine, that will become a non-salient pole machine. तो दोनों में क्या फर्क होगा? यहाँ पर 3000 RPM means how many poles? What is the synchronous speed?
Less 120 FYP. So 2 poles.
Synchronous speed is 2 poles. Yes. (120 F by P) simply. So if you take F as 50 hertz, the P will be minimum number of poles. कितने हो सकते हैं?
2.
Why not 1?
It's a combination of north.
It's a combination of north and south pole. It has to be a pole pair. It cannot be less than 2. So minimum कितना हो जाएगा? कितनी हो जाएगी? 2. 2 means the maximum speed what you get, synchronous speed is 3000. Now is it clear? So if it is a high speed machine, means obviously the highest speed is 3000 RPM, and to match that you have to go for a 2-pole machine which is cylindrical in shape, horizontal. मतलब क्या है कि its axial length is more than the diameter. That's why we call it that this machine will be a horizontal machine. आप देख के बता सकते हैं कि ये steam turbine की machine है या steam turbine unit. So it will be horizontal and more length, axial length, lesser diameter. And now come to this speed lower. If you want to have lower speed, means what does it mean? The poles will be greater. Number of poles will be more. अगर कभी आपने सिंगल फेज इंडक्शन मोटर ये पंखे को खोल के देखा होगा, इसमें नंबर ऑफ पोल्स ज्यादा होते हैं कि नहीं? दो तो नहीं होते, ज्यादा होते हैं. ये चीजें फंडामेंटल थिंग्स हैं, बट मेनी इलेक्ट्रिकल इंजीनियर्स और मैकेनिकल इंजीनियर्स दे डोंट बॉदर टू सी ऑल दीस थिंग्स. आपको ना नाक कान ये सब खोल के रखना चाहिए. And knowledge is there. You have to see it. You have to verify it. I'll tell you a small story. Once upon a time, long back, Rabindranath Tagore, who used to be a big visionary, उनको किसी स्कूल में chief guest बुलाया. You see, so he was called as a chief guest in a very small school. So he used to say कि no मुझे क्यों बता रहे हो आप लोग कर लो. I don't normally go. But he was pressurized and he was finally right there. तो वहां जाके उन्होंने देखा कि one teacher was teaching the student about different kinds of birds, and she was drawing that this is parrot, this is crow, this is your कबूतर, ये वो दुनिया भर की बना रही थी वो. Instead, then Rabindranath said कि you can go outside and show these birds are there, already there. So why don't you show the students, small kids, that this is parrot, this is crow, and so on. ये ज़्यादा impress करेगा उसको, इनकी memory में आएगा. इसीलिए if you see it, if you observe it, you get more knowledge, and that knowledge is a permanent kind of knowledge in your memory. You will not forget it very easily. That becomes a kind of skill. It is no more a knowledge; it is a skill, and skill is a permanent thing. Knowledge is temporary. अब बहुत कुछ पढ़ते हैं in the form of information. You gather and you refine it, that becomes knowledge. But do you remember all kinds of readings what you have done? You don't. धीरे धीरे पुरानी informations fade away हो जाएंगी. New informations will be fed and you will come to know the new informations. So what happens, if you have this skill, once you have learned it, you will not forget it. जैसे ये लड़की जो है, small lady, she is operating the camera so well. Knowledge नहीं है ये, it is a skill. You are soldering a thing, that's not a knowledge, that's a skill. You are swimming, you are driving a car, you are driving a scooter, cycle, ये सब क्या है? Skill है, knowledge नहीं. कभी have you ever heard that he is a very knowledgeable driver? You will always hear he is a very skilled driver. Skilled driver, he can perform this driving very efficiently and effectively. So observe करिए, नाक कान खोल के रखिए, दिमाग को खोल के रखिए. Many things will enter and you will actually get the knowledge, real kind of knowledge, which is not even knowledge. Higher than that, it becomes a skill. So by seeing, come to the point, by seeing you can now say that if it is a axial length is more, it is a horizontal machine, it will be definitely for a steam turbine, means used in thermal power generation. And it is obviously a high speed machine. The other one, which is smaller speed machine, will be, अगर आपको उसको diameter बढ़ जाए इतना, तो किस तरीके दिखेगा? Vertical दिखेगा. So this is a horizontal machine. And this is a you can by seeing tell that yes, A is a horizontal machine used for thermal power generation, B is a vertical machine used for water. So you have different kinds of systems. Now what is a small hydro? Thermal we have studied a lot. The topic is to say something about hydro generation and wind generation, isn't it? And they are now in the cluster of, what is that cluster? Renewable energy generation. Why you call it renewable? Why renewable? The nomenclature is renewable and non-renewable. Earlier we were using non-renewable fuels like coal, paper, wood, husk, anything which was, it cannot be cycled and it cannot be obtained for a definite long time, is non-renewable. उसको renew नहीं कर सकता. But what is solar? What is solar? Is it renewable or non-renewable?
Renewable.
Why it is renewable?
It is because it is provided by nature.
No. Fossil is also provided by nature.
Nature means they are not.
You see, fossil is also provided by nature, but that is not a renewable source. Why solar is a renewable source? Why wind is a renewable source? Why water is also a renewable source? Because there is a cycle wherein you are continuously getting it. There is no storage. No one can say that sun has been stored and उसी से मिलता जा रहा है फिर वो खत्म होता जा रहा है. ऐसा है क्या? आज अगर सूरज उगा है तो कल भी चांसेस है उग जाए अगर बादल नहीं होगा. अगर बादल नहीं होगा तो it will come. So 90% chances are that sun is seen for longer period. It will keep on giving you sun rays, sunshine. Water is a keep on you getting it because it is renewed. हमेशा ये नए तरीके से आपको बनता रहता है. Wind is renewed, solar power is renewed, water is renewed. So they are known as renewable source. But coal, it is not renewing. इसका जो भंडार है उसी में से आप प्राप्त कर रहे हैं. ये भंडार यहाँ है. The other store is here. The other store is here. The other store is here. You are digging. You are trying to find out where is the store. But that store is not increasing. It is limited. So unlimited resource is renewable resource, which is renewed every day. Whereas the coal, the fossil fuel, the wood, the jungle, आप जंगल काट देंगे तो जंगल उगेगा तो नहीं जब तक आप उगाएंगे नहीं उसको. So it will go. That kind of thing. That is why people are saying that go for renewable sources, because the fossil fuel, which is the main source of non-renewable source, that is depleting day by day at a very, very high pace. It deplete होता जा रहा है. इसलिए people are going for non-renewable. So non-renewable का एक सबसे बड़ा जो source है वो है abundance, that is solar. So I'm not touching that in this class. The other one is hydro and wind. So in India also, lot of hydro, lot of wind has started. Another resource क्या है जो non-conventional energy resource है, and that is also a renewable source of energy. Can you tell me what is that? Tidal waves are there. वो उतना नहीं है फिर भी है. Ocean, then magnetohydro, then biomass, biogas. ये भी काफी to some extent a very good renewable sources of energy. Okay, so small hydro is another part of hydro which is being very much tapped at least in 3 states of India. What are those 3 states?
Tamil Nadu.
Tamil Nadu is not small hydro actually, not much. It is the hilly states. Himachal, which is totally hilly, J&K, which is totally hilly, and Uttarakhand, this is totally hilly. Apart from that, there are certain hills in other parts also. For example, your Kerala has got certain hills. Tamil Nadu was also Ooty and small hills. But these states are fully hill. It is a hilly state. They are hilly states. So they have lot of potential. And if I say that 20 to 25% comes in hydro, out of that, other than that, about 5 to 5%, maybe 5% is small hydro. Small hydro. And small hydro का जो latest figure जो हमें पता है, it is about 4200 megawatts. (4200 megawatts have already been tapped, but the potential is much higher. Lot of potential is there, and there is a lot of research going on. I have got one PhD scholar who recently defended his theory, his thesis. You must be knowing, Mr. P.P. Sharma. He worked on small hydro. So small hydro has enough scope. You can also work if you want to go for PhD thesis or some other project. You can prepare a project report also. So small hydro has got a lot of scope. In small hydro, what is happening? It depends on absolutely small power generation. So the units are very, very small. They may be grid connected. They may not be grid connected. Means they are sometimes grid connected and sometimes they are isolated units. So grid connected means what? Hydros are all grid connected. Bigger units, megawatts. Your this thing, Bhakra Rangan Dam is there, Rihand is there. So many hydropower stations are there. But small hydro is very few, very small. You will be surprised to know that in Himachal and in J&K there are pico hydropower generations also, as I said. Pico is very, very small. What are they doing? That there is a cluster of village of say 10 families, 10 houses. 10 house वाला एक छोटा सा village है. उसको भी power दिया हिमाचल में, J&K में. कैसे दिया? That if small unit is there, small head is created through the river parts or the springs or water, rains, etc., etc. That head is the energy source. So होता क्या है कि what is happening in hydropower generation? Thermal power generation कैसे generate करते हैं? You have to know a little bit of it.
Steam.
No, steam कैसे करते हैं? What is the principle?
Coal.
The resource is coal. Is it pure coal or something else?
No,
No, there is no pure coal.
Oh, the coal is not pure. It is processed in coal processing unit.
Yeah, coal processing unit करके
Pulverization.
pulverize वगैरह कर दिया. पहले तो what is the quality? What is the factor or feature on which the quality of coal depends? Can you tell me? किससे आप कहते हैं कि ये good coal है, ये bad coal है? How do you say?
Heating capability. I forgot the word.
Forget the units. Sir.
It is the calorific
Calorific
value.
value.
CV. CV तो आपने पढ़ा होगा ना physics में. Calorific value is the index of quality of coal. If the CV is high, it is a good quality coal. If the CV is low, its quality is lower. Now, what are the impurities which come in coal and deteriorate its quality. One is dust, moisture, foreign particles. Because coal it is coming from the earth and it is a pure fossil fuel. So what is happening is these dirts or these impurities which are also there in the earth, boom, it is also getting mixed with it and the coal quality is deteriorating. What are the, by the way, what are the places in India where you get coal?
One is Chandrapur.
Chandrapur is in Maharashtra. Then the biggest
Odisha.
Bihar, Bengal, Odisha, right? Jharia, Asansol. Then your what is that?
Eastern region most.
It is eastern region. And then to some extent, little bit in Maharashtra, little bit in south also. Now what is happening? Your thermal power generation may be in extreme north. The coal has to come from east. तो क्या करेंगे आप? Wagon में भर के ले जाएंगे, transport होगा. Lot of energy wastage is there. Again, it's a question of energy management. What to do? You have to send the coal there because you cannot have the thermal power generation only in eastern region. You have to have thermal power generation in western region. You have to have it in southern region, in central region, all. So transportation is a very big problem. Although all those problems have been tackled to some extent, and you know that these are the problems, the policymakers know that, everybody. But even then, it is 65% generation is coal. Why? What is the reason? Renewable sources को क्यों छोड़ दिया? इसके ऊपर concentration है. But what is the reason why you are not actually achieving? Why not totally renewable? Why can't you get it? Totally renewable sources, if you can manage, I think that would be definitely better, superior power generation system. But you cannot do it. The question is, you cannot do it. Why?
Source of money.
Resource is in abundance. Sun is in abundance. Water is in abundance.
Technological aspects are not that much sound with respect.
Tell me what economical aspects. I know that solar generation is not an economical criteria. Yes, it is not. Similarly, your wind, similarly hydromagnetic, magneto-hydro, and so on, biogas, biomass. In bulk, you cannot have it. In small amount, you can have it. For research purpose, you can have it. Theoretically, it's okay, but practically, it doesn't stand. What is the reason? The main reason is the technology is not foolproof. The technology what you are using, say PV generation or thermal generation by water heating or solar heating, is not known to us. It is not foolproof. We are still importing the theory and also technology, and also we don't have the technical know-how. वो जब तक efficient नहीं होगा, the process is very, very inefficient. As I said, the PV generation is about 22% or so. The maximum it has gone up to 25%. So 25% में इतना ताम झाम करने के बाद अगर आपको generation मिल गया, it is a very funny thing. That's why people are doing lot of research. It is in the agenda, no doubt, for the next 5-year plans, but it is not coming up that way. Right? So these are the problems. Anyway, so small hydro में उन्होंने क्या किया कि pico hydro किया एक cluster of villages करके उनको power दिया. Then they have micro stations. They have small hydro. Small hydro is in say 1 megawatt or so, but micro and pico are still small. So they can be either grid connected or they can be standalone systems. Now why you go for grid connected systems?
So when grid is not able to go, there standalone systems are used.
Because grid is not available everywhere.
Yes.
It is a remote place. I said the pico किसी JNK के या हिमाचल के remote village में लगा दिया, power तो मिल गया, तो वहाँ पर तो आपको grid ही available नहीं है, तो कहाँ से जोड़ेंगे? Second thing, grid connection means you have to have that parallel operation system, and you have to have matching, voltage matching, frequency matching, phase, etc., etc., which are highly technical, and these problems are not very easily solved. It cannot be addressed very easily, and that's why we better go for isolated systems. But isolated systems are उसमें क्या disadvantage isolated?
Once the supply fails, once the
reliability is the biggest problem. It is the biggest problem. Second thing is, you know, lot of heat is produced. तो वहाँ पर एक dump load use करते हैं. Have you ever heard of it? Have you ever seen? You have not seen a thermal power generation. You have not seen a hydropower generation. Small hydro to दूर की बात है. You must see. You must go and see all these things. Then only you will be able to appreciate. Small hydro में आपका dump load use किया जाता है. Dump load means the heat what is generated is cooled through the water. And then I asked a question to the वहाँ पर जो थे वो लोग chief engineer. Hey, what are you doing with this wastage of heat? It's a kind of wastage of heat because you have to cool it, so you are using water load, that is dump load. He said कि ये पानी गर्म करके ऐसे गाय भैंसों को नहा देते और कोई यूज नहीं उसका, because you will not be able to produce steam out of that. That is not possible. Only thing is warm. So that kind of thing is there. Again, it is a technical know-how which has failed. So I want to tell you the point that so far as the technology is superb, it is foolproof. You know it. You stand on your own technology. The renewable sources are not very, much in practice. They are either trying to do it. A lot of research is going on, but it will take time. इसीलिए कहते हैं कि जब तक वो नहीं है तब तक आपका थर्मल पावर जनरेशन हाइड्रो मेन तो होता ही रहेगा. होता रहेगा कि नहीं? टू सम एक्सटेंट न्यूक्लियर हो जाएगा. न्यूक्लियर में क्या प्रॉब्लम है? व्हाट इज द प्रॉब्लम?
Radioactive waste.
It is radioactive is best is that's a dangerous thing for health. But main thing is the fuel is not available. Uranium-92 is not available here. So you have to purchase, and that deal, nuclear deal was, it's a big deal. So France, we are approaching US also, Russia also. But it is again a politics. It is a problemous thing. So you cannot अचानक depend करने लगेंगे. Nuclear generation is hardly about 1.5 to 2%. But we have been talking of nuclear power generation for ages now. Why? The technology has not come up to its mark. So what is the solution? आपको thermal में ही रहना होगा. Thermal का biggest disadvantage ये है कि you are eating away your fossil fuel, depleting. After 200 years there will be no fuel. What will you do? तो आपका एक ही इसके पास solution है जो yesterday I deliberately told you that it is the conservation. आपको यूज भी करना है और ऐसे भी यूज करना है कि ये सारा कुछ खत्म हो. तब तक एटलीस्ट करना है जब तक रिन्यूएबल एनर्जी सोर्सेज पे आप बिल्कुल स्टैंड हो. When the renewable sources will replace this total scenario, then only you can say कि yes, we are now safe and there will be no energy crisis in the world. Now let us see some of this thing, and let us दूसरा जो आपका है विंड का क्या है सिनेरियो? व्हाट इज द सिनेरियो? विंड में क्या करते हैं? नाउ यू आर वेरी क्लियर दैट इन स्टीम जनरेशन, एज आई वाज टेलिंग यू, उसको थोड़ा बता देते हैं कि कोल इज द रिसोर्स, नो डाउट. कोल को आपने पत्थर की तरह मिलता है. उसको पहले वैगन से ले आते हैं, फिर वैगन ट्रिपलर से उसको गिराते हैं, फिर उसको पीसेस में तोड़ते हैं. यू ब्रेक देम इनटू पीसेस एंड देन यू पल्वराइज इट टू बॉल मिल्स. बॉल मिल्स में उसको घुमा के उसको पीस देते हैं, पाउडर. आफ्टर दैट व्हाट हैपेंस?
Dry up.
पाउडर को यूज करते हैं? नो. यू मिक्स अप सम ऑयल विद इट व्हिच इज नोन एज पेट्रोलियम जेली और ऑयल. व्हाई डू यू मिक्स ऑयल टू इट? तो ये एक लुगदा सा पेस्ट टाइप बन जाता है. दैट बिकम्स अ पेस्ट. अदरवाइज इट वाज अ पाउडर. Now it with the some quantity of oil which you get as a petroleum oil, petroleum product, you mix it, it becomes a paste sort of thing. And then in the furnace you throw it by guns at a very high speed. कभी देखा आपने? अब तो देखा ही नहीं. फर्नेस जाके देखिए, उसके अंदर वो फर्नेस है और बॉयलर लगा हुआ. बॉयलर में क्या है? वाटर. बॉयलर हैज वाटर and this furnace is generating heat. So it is a डायरेक्ट हीटिंग बॉयलर और ना लैंकाशायर बॉयलर वगैरह उस टाइप का बॉयलर है. उससे आप हीट जनरेट कर रहे हैं एंड द वाटर व्हिच इज केप्ट इन द बॉयलर इज बीइंग हीटेड अप टू मैक्सिमम टेम्परेचर एंड मैक्सिमम प्रेशर. तो वो स्टीम जनरेट होता है. दैट स्टीम इज नोन एज सुपर सैचुरेटेड स्टीम. उसको ड्राई स्टीम भी बोलते हैं. ड्राई स्टीम मीन्स देयर इज नो मॉइस्चर कंटेंट. इट इज प्योर स्टीम, देयर इज नो मॉइस्चर कंटेंट. वो कब आएगा? सुपर सैचुरेटेड, सुपर हीटेड स्टीम बोलते हैं. तो उसके लिए आपको कोल को इतना गुड क्वालिटी होना चाहिए that creates by burning that it creates that much of heat, अदरवाइज तो होगा नहीं। इसीलिए कोल का क्वांटिटी जो है, क्वालिटी जो है, शुड बी वेरी वेरी गुड। वो जो आपका स्टीम बना, that steam is fed to the steam turbine. The turbine rotates at 3000 rpm and it couples with the alternator. The alternator also moves. It's a two-pole machine and electricity is generated. This is the basic principle of coal thermal generation. Of course, here water is treated. Water treatment plant hota hai. It is treated. Why it is treated? pH value maintain करते हैं, so that there is the efficiency should be as good as possible. ठीक है। उसके बाद कोल हैंडलिंग आपका यूनिट होता है, बेल्ट कन्वेयर बेल्ट से ले जाते हैं, और वो लोहा लक्कड़ जो उसको अंदर होता है, those are separated out with the help of coils, right? All those things are done, pulverized this that, then finally ये हो गया। Now how do you generate water? Hydro generation? हाइड्रो में यही चीज आप क्या करते हैं, वाटर हेड की एनर्जी को यूज करते हैं। हियर यू आर यूजिंग द स्टीम एनर्जी व्हिच इज अ बाय प्रोडक्ट ऑफ कोल बर्निंग एंड वाटर हीटिंग, इज इट नॉट? एंड हियर in hydropower generation, what you are doing, you are having a dam and the water head is created by falling that water from very big height to the blades of the turbine. तो वो अपने वेट से जो गिरता है वाटर हेड, उसकी वजह से वो टरबाइन को रोटेट करता है। And that is why that turbine cannot have that much speed what a steam turbine can. तो water head की जो एनर्जी है उसको आपने कन्वर्ट किया, this turbine is now coupled to an alternator and it produces electricity. This is, and what is the principle of wind power generation?
The wind is imparted on the blades of the
windmill. Yeah.
And then they rotate. And small alternator is connected to it. So accordingly, electricity is generated.
There are two ways. One is this windmill generation, as you said. It is very popular in states like Maharashtra, in states like Rajasthan, Gujarat. तो गुजरात में भी कोस्टल में बहुत ज्यादा है, but yes, बहुत ज्यादा है, and Rajasthan also. Solar is also very popular in Rajasthan. Solar is also popular in Gujarat. Wind में आपका दो किस्म का है. One is aero generator. Aero generator is a dynamic machine which is double fed induction generator. So induction generator use करते हैं इसके अंदर, और वो जो है generate करता है आपका electricity. For it is DC operated and then it is inverted and converted into AC. इसके लिए आपको wind की पोजीशन, विंड की जो प्रोफाइल है, दैट इज वेरी वेरी इंपॉर्टेंट, एंड इट इज वेरी ऑब्वियस दैट विंड शुड बी देयर. अब कभी तो जैसे इस समय देयर इज नो विंड एट ऑल, इट इज ऑल स्टेशनरी, सो विंड जनरेटर विल फेल हियर. यू गो टू द कोस्टल एरियाज वेयर ऑलवेज देयर इज अ विंड एंड देयर इज अ वेलोसिटी, दैट मिनिमम वेलोसिटी जिसको बोलते हैं विंड वेलोसिटी, दैट हैज टू बी देयर, दैट विल रोटेट द विंडमिल. वन इज दिस, अनदर इज योर aero generator. Aero generator is a special type of generator which is designed so that whenever there is a wind flowing, it will generate electricity accordingly. But the biggest problem is the frequency. If the wind is turbulating, कभी ज्यादा हो रहा है कभी कम हो रहा है, तो frequency matching will be a problem. So you have to have lot of technology in it to match the frequency and to get the output. So these are basically the three rather renewable energy sources which are now getting popular in India also. One is solar. Solar has come up, PV has come up, but again I will say that the efficiency is not very high. Efficiency is quite poor because the materials are not good. जो आपका क्रिस्टल है वो उतना ज्यादा, उसमें भी बहुत रिसर्च हो रहा है. It is a different kind of materials are being now tried whose efficiency right now they have claimed that it can go up to 40%. अगर 40% हो गया तो फिर it is as good as better than thermal. What is the efficiency of thermal generation? Can you tell me?
Around 40.
It is less than 40%. It is less than 40%. Why? क्यों इतना कम? Where is the loss?
Different losses at different stages.
Where is the biggest loss?
In the fuel itself.
In the machinery, you talk about the machinery.
But when we burn the coal and water gets heated in during
You see, generator is a very highly efficient device. Alternative. Now come to the turbine. Turbine is a mechanical device, and yeah, it has got the maximum loss. The turbine की efficiency, boiler की efficiency, these are the culprits. यहीं पर आपका pitting हो जाता है, efficiency down. On the whole, efficiency will be efficiency of turbine into efficiency of boiler into efficiency of generator into efficiency of transformer. तभी तो power हो गया. तो ट्रांसफार्मर की एफिशिएंसी कितनी है?
Max.
Sir, it is again maximum देंगे, it will be 98, 99.
99. So it is more than 90%. Generator also is about 85, more than 85%. It is the two culprits are generator, turbine and boiler. Their efficiency is very, very less. So when you multiply, the total efficiency आपकी बहुत कम हो जाएगा. That's why thermal power generation, if it has reached 40%, means it is quite good. There is one power generator, Renukoot power plant in UP, that has got an efficiency of 45%. Very high. Ropar thermal power is also quite high, क्योंकि इसमें यहाँ static excitation used किया. You know, static excitation that has been used. Clean बहुत है. And Renukoot is very, very clean. That's a private. It is Birla's का है वो, Hindalco. So that's why there are few. But mostly, अगर आप देखेंगे, efficiency is 36%, 35%, 32%, something like that. So अगर आप PV 40% achieve कर सकते हैं, I would say it is good. तो वो हो रहा है. But it cannot replace the thermal power generation because it is in bulk generation. Now let us see some of the things through our slides. बताओ, slide 1. लाइट्स थोड़ा ऑफ कर देंगे. लाइट ऑफ तो वो करो ना.
क्या हुआ है सर?
इतना ही बड़ा है ना. ओके.
Next.
But I think the contents are the components of power system, the generation capacity of and demand, the projections, major reasons for power sector ills, hydro, wind and PV power generation. I would like to tell you a little bit of PV also and hybrid power generation. Now what is a hybrid power generation? You see, we have been talking of renewable sources of energy, means renewable power generation, is it not? We are talking of renewable. So renewable में देखा लोगों ने कि if one technology is there, it has got certain merits, certain demerits. Now there is another technology, it has got some other merits, some other demerits. There is a third technology which has got other merits and demerits. Now one chap thought, why not we amalgamate all the three technologies and get the merits of all? So that is known as hybrid power. So hybrid power, can you name? It is solar, wind, what cell?
Fuel cell.
Fuel cells, then battery. If you can have all these things, it is known as hybrid power. Next. So power, the building block of economy. We always say the power is the building block of economy. Yesterday I told you about this. Electricity, the most important infrastructure input in the development and growth of economy. I said it is the index and it is the per capita consumption. One in a country is known as a developed country if its per capita income and per capita electricity consumption is high. Then consumption of electricity, important index. Then economic growth rate of 8 to 9% on sustained basis. Now we are claiming right now it is about 7 point something, and 7.7. The maximum is what 8.9% was achieved. It is again the power system which gives you the idea. Otherwise, if you have the power generation, you will go higher and higher. It is obvious. 2/3 of the electricity of electrical generation of the world, yesterday I told you, it is consumed by 1/4 population of the world, and 1/3 of the total electrical is consumed by 3/4 population. This is an irony, very big irony. And unless you improve this ratio, nothing going to happen. Next. Now these are the components of power system. You can very easily see the components are there, the fossils are there, transformer is there, then lines is there, then transform substation is there, so, your transmission lines are there, 450 volt is that battery, second substitution, etc. Next. हल्का सा आ रहा है ये. इसको थोड़ा ऑफ करेंगे.
Sir, last year.
हाँ उनको कलर ही थोड़ा कॉम्बिनेशन ठीक नहीं किया. आई वुड हैव, मैं बैठा नहीं था ना स्लाइड पर, मैंने उनको बोल दिया था. So he was making. Anyway, generation has thermal power plant, that's solar, hydro power plant, nuclear power plant, diesel power plant, gas power plant, combined cycle power plant. All these are generations. Then solar, tidal, wind, geothermal, biomass, and fuel cells. These are the sources. Out of which your thermal, basically diesel, gas, these are all fossil fuels users. So they are your conventional generation, and rest all are non-renewable sources. Now see, ultimately the paradigm shift will be what? The paradigm shift will be from renewable to non-renewable to renewable. This will be the paradigm shift. And also one more thing, one is the energy efficient devices. अभी वो भी एक बहुत important चीज है. That energy efficient devices अगर आप use करें, so you can do the same task by using lesser energy. For example, your fluorescent lamps, CFLs, LEDs, these are energy efficient devices. Electronic chokes. Then there are CDs now. You see, आप एक ऐसा आ गया है कि cooling chips बोलते हैं उसको. These are semiconductor devices, cooling chips. It is a CD-ROM size. And you can portable type. आप पॉकेट में लेके इसको चले जाइए, उसमें just 220 volt का सप्लाई दीजिए. It can cool as much as a 1 ton AC can cool. इसको बोलते हैं cooling chips. Now these are the inventions. The biggest inventions or research are in the field of material science. You see, ये सारा कुछ material science का देन है. I always plead that the material science should be a very core, important core subject of any engineering. जब तक मटेरियल साइंस आप नहीं जानेंगे, प्रॉपर्टीज नहीं जानेंगे, क्या है सेमीकंडक्टर मटेरियल ही तो है. पहले इनर्ट गैस लगाते थे, ये लगाते थे, ट्यूब्स लगाते थे, अभी आजकल सेमीकंडक्टर्स लगाते हैं. So it is a material, right? So always there has been a research in it. So like that you are improving. Then there is a material called hot semiconductor, a superconductor device. Hot superconductor. Have you heard of it? What is that? Superconductors are those material which will have no resistance at all. That means total conductance. जब resistance ही नहीं हो तो loss भी नहीं होगा. It is known as superconductor. But operation is at very low temperature. बहुत कम, -270 डिग्री केल्विन पर वो काम करता है. तो उसका यूज होना ना होना बराबर है. Whether it exists or not, it doesn't matter to us because we have to work on the room temperature. सब जीरो पे नहीं काम करना है. Now people thought, can we have some amalgamation, some mixture, some compound, some mixing these things, alloys, etc., to have properties of a superconductor at a higher temperature also. Now they have discovered hot superconductor material, which can work not at -273, but it can work at 0 degrees Celsius. तो यहाँ तक उन्होंने पहुँचा दिया. Still research is going on, and there is a company, Hoover's company in US, which has manufactured transformer and generator, one set each, which is working 100% efficiency at the poles. Poles में sub-zero temperature होता है, वहाँ ये काम करता है. अभी भी रिसर्च चल रहा है, so you can further improve. अगर ऐसा एक दिन आ जाए कि सुपर कंडक्टर आपका रूम टेम्परेचर मिल गया, तो आपका सब प्रॉपर्टी, सारा प्रॉब्लम सॉल्व हो गया इलेक्ट्रिकल में. देयर विल बी नो लॉस एट ऑल. ठीक है. सो लाइक दैट यू हैव डिफरेंट काइंड्स ऑफ जनरेशन. नेक्स्ट, ऑल इंडिया इंस्टॉल्ड जनरेशन टोटल इज 15. दिस वाज earlier, I think 1547969. Hydro was this much, nuclear was this much, and rest was this much. It's an old style. Next. Breakup generation. Installed capacity of power plants in India at the end of year 2013 was 2,33,929. But now it is 284. 284 is the latest. The thermal was 68%. The hydro was 17.42. The renewable contributed next 12.39 and nuclear only 2.1%. So you know that nuclear has got, although nuclear technology is a very old technology, it's established technology, but its efficiency is very less. आजकल हम लोग क्या बोल रहे हैं reactors, कौन से reactors? No, nuclear reactors are there. Fast breed, hybrid reactors. तो उसके अंदर न्यूक्लियर में आपका fission and fusion दो processes होते हैं. There are two processes. One is known as the fission process. The other is fusion. Fission process is the older one जो हमारा चल रहा है. उससे आपका क्या होता है कि when there is a bombardment, then the nuclear is broken into more, and that radiates energy. उस energy को हमने use करना है for heating water, isn't it? Instead of burning coal, I am using this bombardment process. और अगर इसको हम कूल ना करें, इतना ज्यादा एनर्जी आ जाएगा तो क्या कर देगा? न्यूक्लियर आपने पढ़ा है कि न्यूक्लियर? So there is a heavy hydrogen used, which is nothing to cool the process. Heavy hydrogen, heavy water बोलते हैं इसको. Deuterium, D2O, that is heavy water. Heavy water is used for cooling down. That means जो एनर्जी है उसको थोड़ा स्लो डाउन करता है. स्लो चेन रिएक्शन को स्लो कर देता है. स्लो करने से आपकी उतनी एनर्जी नहीं रेडिएट होती जितनी उससे हो सकती है. अगर ऐसा ना करे तो क्या होगा? This is very important step of nuclear generation.
चेन रिएक्शन से कंटिन्यू बढ़ती है.
लास्ट हो जाएगा. इट विल बी न्यूक्लियर जनरेशन की जगह ये न्यूक्लियर बॉम्ब हो जाएगा. इट विल बी एन एटम बॉम्ब और न्यूक्लियर बॉम्ब. ब्लास्ट हो जाएगा. दैट्स व्हाई दैट इज वेरी
मॉडरेटर. आई थिंक
मॉडरेटर उसी को बोलते हैं जो स्लो डाउन करता है. इट इज नथिंग बट हेवी वाटर. ओके, नेक्स्ट. Per capita energy consumption in various countries 2009 to 2010. This is a very important slide. Per capita consumption. इसमें इंडिया का स्थान बहुत कम है. इसमें थोड़ा कम दिख रहा है. India is very less. इंडिया है ही नहीं. इसमें इंडिया का 1000 यूनिट है.
Yes, sir, last. Second last.
Second last is India. So India bar you can see. So now that is the thing. This is the irony. I was telling you that per capita consumption is important. It is not that you have generated 2,84,000 megawatts or 2.284 gigawatts. आजकल गीगावाट से भी ऊपर जा रहा है. टेरावाट्स बोलते हैं. टेरावाट्स है ना. बट व्हाट इज द यूज? इतना ज्यादा पॉपुलेशन है, इतनी अधिक मतलब कंज्यूमर्स है आपके, that many people do not know what is electricity. Still आज के दिन में many people in the country do not know what is electricity and what is its application. जबकि हम ज्यादातर लोग जो शहर में रहते हैं या some elite class we are electrically driven. As I said, I use this word that your every step it goes with the help of electricity. But there are still people who do not know what is electricity and how does it function and what are its operations. So ये irony है. So per capita consumption is very less. This is very important. Next. India energy needs. India's energy क्या need है देखिए. Energy intensity is energy consumption per unit of GDP. ये चीज आप देखिए. मैंने आपको yesterday I told you that energy consumption और per capita consumption is directly related with GDP. और GDP जो है वो सारे वर्ल्ड मार्केट में बोलता है कि किसका GDP हायर है वो कंट्री एडवांस्ड है. Most places. It is written that energy intensity is energy consumption per unit of GDP. What is the GDP of India right now? What percent?
7%.
It is less than 8%, 7.9 or so. Anyway, high energy intensity points to energy wastage in economy, which can be minimized through efficient use of energy. Yesterday I told you all this. India's energy intensity is 3.7 times of Japan, 1.55 times of USA, 1.4 times of Asia, and 1.5 times the world average. But the per capita consumption आपने देखा. We are even worse than Sri Lanka. I am telling you. That is the irony. बहुत खराब हालत है. Next. So all India energy and peak deficit इसमें ग्राफ में बताया. Next. Key performance indicators to overcome illness. Illness means there is something called illness in the power this thing. Otherwise ये होगा क्यों? Can you tell me what is the power industry illness? What are those things जिसकी वजह से इतना generation है? Even then, one is the population of course, but what other factors are there which affect? One is political will. Can you give me an example? Political will का example दे सकते हैं? हर MP MLA कहता है कि हम यहाँ फ्री में इलेक्ट्रिसिटी दे देंगे. हमारा किसान जो है काम करेगा उसको इलेक्ट्रिसिटी पे नहीं करना. He becomes a cannon. है? उसको क्या पता कि इलेक्ट्रिसिटी कैसे जनरेट हो रहा है, बट ही विल अनाउंस एंड ही विल डू दिस. MP MLA मंत्री संतरी सारे लोग ऐसे लोग पंजाब में एवरीवेयर. पंजाब में तो बहुत ज्यादा है, हरियाणा में भी है. दिस इज अ पॉलिटिकल विल. व्हाई? या यू मे हैव सर्टेन, थोड़ा सा उनको वो दे दो, छूट दे दो, बट व्हाट इज दिस एनी अमाउंट दे विल यूज. एंड वो कटिया तो अलग से लगाता है. I was there, strange in his, I saw one thing that a person was doing that. I said, what is this? Why are you using? कहते कि डांगरू नु नहलाना जी, पानी गर्म कर रहा. डंगर कहते हैं वो उनको, भैंस को, उसको गर्म पानी से नहलाएगा. This kind of thing. So another thing is, apart from the efficiency of the system, political will, then your equipment outdated equipment लगा रखा है. Then your technology itself. So these are very, very important. So illness here, energy consumption management, paradigm shift from non-renewable energy to renewable energy source, energy intensity technology, energy efficient technology. This is also very, I told you, energy intensity technology से आप जाइए energy efficient technology. क्या करते हैं आप? अभी जो भी आप यूज करते हैं, चाहे वो हाइड्रो पावर हो, चाहे वो न्यूक्लियर हो, चाहे थर्मल पावर हो, इलेक्ट्रिसिटी व्हेन यू यूज, तो आपका कंजम्पशन बहुत ज्यादा है एज कंपेयर टू योर आउटपुट. जो टास्क है उस टास्क को करने के लिए आपको लेसर एनर्जी में भी हो सकता है, बट यू आर यूजिंग लॉट ऑफ एनर्जी. सो दिस पॉइंट इज वेरी वैलिड. एनर्जी इंटेंसिव टेक्नोलॉजी टू एनर्जी एफिशिएंट टेक्नोलॉजी आपको बदली करनी है. मैंने आपको एनर्जी एफिशिएंट टेक्नोलॉजी का एग्जांपल दिया. CFL, इलेक्ट्रॉनिक चोक्स, एनर्जी एफिशिएंट मोटर्स, योर LEDs. देन जैसे हमने कूलिंग चिप बताया, हॉट सुपर कंडक्टर्स, ये सारी टेक्नोलॉजीज आ रहे हैं. इसको यूज करेंगे तो आप ज्यादा एनर्जी यूज नहीं करेंगे, एनर्जी एफिशिएंटली यूज करेंगे. दैट इज व्हाट इट इज. So energy crisis I have already explained. Quickly chalo, time nahi. Now hydro, wind and PV. So these are, as I said, these are main hydro. You have a dam. You use the energy of the water head या water table बोलते हैं उसको. जितने ऊपर से आप गिराएंगे उतनी ज्यादा एनर्जी आपको मिलेगी. इसके ऊपर, किसके ऊपर गिराएंगे? टर्बाइन ब्लेड. Then you can obtain it from the glaciers. जहां पर ग्लेशियर होगा वहां स्मॉल हाइड्रो का आप यूज कर सकते हैं. ग्लेशियर्स आर इन हाई पीक ऑफ द स्टेट्स, हिली स्टेट्स. नेक्स्ट, नाउ हाइड्रो इलेक्ट्रिक पावर जनरेशन. दिस इज वर्टिकल मशीन. दिस इज ये वर्टिकल. आप कह रहे थे ना कि ऐसे घूमता है, वो ऐसे घूमता क्योंकि वो दिखता ही है वर्टिकल, इसलिए वो ऐसे घूमता है. दिस इज डैम, रिजर्वॉयर, जनरेटर. दिस एवरीथिंग इज नोन टू यू. So this is the way, that is the turbine, and the turbine, as I said, is a low speed machine. So one number of poles are more. It is a your salient pole machine. High number of poles are more, not salient machine. So output like this. Next, major hydropower plants in India. It is in fact the case that major hydropower plants in India are situated in regions of the major rainfall. जहां मेजर रेनफॉल होगा वहीं होगा। पानी आपको चाहिए ना। देयर आर टू थिंग्स, वन इज द रिजर्वायर, वन इज द कैचमेंट एरिया। ये डिफरेंस क्या है दोनों में?
सर कैचमेंट की जब बर्फ पिघलती है तो थोड़ी थोड़ी छोटी छोटी स्क्रीन से आती है, फिर वो देन से कैचमेंट एरिया डिफरेंट है। उसके बाद जब उनको आप इकट्ठा करते हो इन पूल या स्ट्रीम को इकट्ठा करते हो,
दैट इज द रिजर्वायर। एंड द रिजर्वायर जैसे डैम बोलते हैं ना, रिहन डैम, वो नदी, दैट इज रिजर्वायर। बट कैचमेंट इज दैट जहां पर पे और भी जगह से पानी आके इकट्ठा हो, एंड देन इट गोज टू द रिवर, एंड रिवर टेल्स यू द रिजर्वायर। रिजर्वायर से फ्लो करा के उसको फिर डैम से गिराते हैं। दिस इज व्हाट इज द मैटर। So these are the areas where you have major hydropower plants. Next, annual rainfall map. कहाँ कितना पानी बरसता है? You see earlier it was Cherrapunji. This was the highest rainfall. अभी चेरापूंजी नहीं रहा. There is another place called, उसका नाम मैं exactly नहीं भूल रहा हूँ उस समय, जो कि बिल्कुल उसके पास ही है थोड़ा, and it has beaten चेरापूंजी. चेरापूंजी से ज्यादा rainfall है. And I've been to चेरापूंजी. मैं चेरापूंजी में गया हूँ, जिसमें साल में हमेशा पानी गिरता रहता है एंड धुंध छाया हुआ रहता है। इट इज द हाईएस्ट रेनफॉल। सो वहाँ नेचुरली रेनफॉल जितना ज्यादा होगा उतनी कैचमेंट आपको ज्यादा होगी, और कैचमेंट जब ज्यादा हुआ तो फॉलोइंग दैट रिजर्वायर। नेक्स्ट, ऑफ कोर्स हाइड्रो इलेक्ट्रिसिटी के क्या क्या एडवांटेजेस हैं? यू नो, द रिक्रिएशनल अपॉर्चुनिटीज, फिशिंग, बोटिंग, देन ड्रिंकिंग वाटर सप्लाई, फूड कंट्रोल, वाटर फॉर इरिगेशन, एटसेट्रा एटसेट्रा। Because this is a natural energy and it is in abundance. अगर आप उसने यूटिलाइज, आपने उसको प्रॉपर्ली यूटिलाइज कर लिया, then it has got very very big advantages, है ना? एंड हाइड्रो का जो अगर वो है कॉस्टिंग देखा जाए तो यूनिट कॉस्ट में भी ये थोड़ा कम ही आता है देन इन एज कंपेयर टू थर्मल। बट कंस्ट्रक्शन ऑफ डैम इज वेरी वेरी कॉस्टली। मतलब पहले आपको पैसा बहुत ज्यादा खर्च करना पड़ेगा, बाद में the maintenance cost and the operating cost is not much. It's lesser. Next, disadvantages of course. Hydroelectric power plants that require the use of dams can really affect the flow of rivers. कई बहुत सारे नेता लोग उसको अपोज करते हैं ना, इकोसिस्टम को वो कर देता है, अनबैलेंसिंग करता है। बट एट द सेम टाइम इफ यू गो फॉर इट further, that fuming is not there. NOx, COx, SOx, ये सब होते हैं ना fuel gases. NOx means sodium nitrogen gases. Then sulfur gases. Then carbon monoxide, carbon. ये सारी gases जो है they are very poisonous and they may even cause cancer. इन सबों को इसमें से आप रोक सकते हैं। पहले तो आपने दूसरी तरीके से तो थोड़ा बैकेज कर दिया उन्होंने, बट आगे जो है वो एटमॉस्फेरिक पोल्यूशन इससे कम होगा। नेक्स्ट, इम्पैक्ट्स ऑफ हाइड्रोइलेक्ट्रिक डैम्स, क्या क्या इम्पैक्ट्स है वो दिखाया। नेक्स्ट, सोलर एनर्जी, ऑफ कोर्स सोलर का इसमें इसको स्विच करो। पीवी सेल कहाँ कहाँ पर वो दिखाया। टिपिकल फोटोवोल्टाइक सेल, दिस इज द मेथड। देन नेक्स्ट, एडवांटेजेस ऑफ पीवी। पीवी का क्या एडवांटेज है? मेन पीवी का एडवांटेज क्या है?
Free and abundant.
It's a free energy. It's a neat energy, right? It's a very neat energy. Pollution free. That's very neat. Less maintenance cost. Next, disadvantage यही है कि variable energy source with energy production. और इसमें आपने पता नहीं आपने कभी लगाया है कि नहीं, सोलर थर्मल स्टेशन, सोलर जनरेशन हमारा यहाँ लगा हुआ है। इसका एक आइडियल टाइम होता है। The biggest disadvantage is, don't think that it is irradiation of the sun rays that is important. It is not the temperature. Temperature तो 45 डिग्री सेल्सियस हो गया, 50 डिग्री हो गया, तो उस समय जनरेशन क्या होगा? The curve is lesser. The optimum temperature is about 25 डिग्री सेल्सियस। तो अक्टूबर का महीना जो है, अक्टूबर नवंबर, ये महीना सबसे हेल्दी जनरेशन होता है। That is the biggest disadvantage. अभी देखिए, किसी ने बोला कि वहां पर ठंडा कर दो उसको, ठंडा करने में तो आप एनर्जी यूज करेंगे, तो वेयर इज द रिन्यूएबल एनर्जी देन? इफ इट इज रिन्यूएबल एनर्जी, यू डोंट हैव टू यूज अ कूलर और यू डोंट हैव टू यूज दैट, द टेक्नोलॉजी इटसेल्फ हैज इसको मार खाया हुआ। तो वो इंप्रूव करने के रिसर्च चल रहे हैं कि क्रिस्टल को कैसे इंप्रूव किया जाए, मटेरियल को कैसे इंप्रूव किया जाए, उसकी रेडिएशन प्रॉपर्टी को कैसे। अगेन इट इज द मटेरियल साइंस व्हिच कम्स इन पिक्चर। Next. Large scale solar, देखा ही होगा ना panels. Small scale solar. Next. Installed solar power capacity as of 30 September 2000. ये दिया है कहाँ कितना. Next. Growth trajectory of total solar installed capacity. कैसे देखिए 31/3/2009 में कुछ भी नहीं था, फिर बढ़ते वहाँ चला गया. It is the growth. There is no doubt that this technology is coming up, but there is a limit, and it is going very slowly. Efficiency is less. Next, National Solar Mission. चलो बताओ next. Wind energy. Wind energy का ये दिखाया देखिए windmills जो हमने आपको बताया. Next, इसको बोलते हैं back करो. What is this known as? देखा है कोस्टल एरियाज में होता है, इसको विंड फार्म्स बोलते हैं. एक के बाद लगा हुआ. वाई इतने सारे क्यों लगा दिया? बिकॉज द पोटेंशियल इज वेरी हाई. आपके पास इतना ज्यादा विंड अवेलेबल है, इतना ज्यादा उसका पोटेंशियल है कि एक बहुत बड़ा विंड मिल आप जनरेट नहीं कर सकते. उसकी जगह पर व्हाट वी हैव डन इज वी हैव डन नंबर ऑफ विंड मिल्स एंड दैट इज विंड मिल फार्म. And what you do is you have to get the maximum efficiency out of it. इसमें से कुछ मैंने देखे, I have seen in Gujarat especially that some of them are not rotating, but on the whole it is still generating power. Someone is not rotating, the other one is rotating. Orientation उसका degree ऐसे लगाया हुआ है. Someone is rotating in the same atmosphere and it is producing power. And this is always grid connected. Grid connected. ये wind power generation जो है grid connected. Next. So this is the estimated wind power potential in India. They are state-wise. They have shown this in this slide. Okay. Next. खत्म है. I have finished. Advantages, of course. One of the most environmental friendly. Wind is environmentally friendly. Then it has the lowest generation. What is that? I cannot read here. इतना हल्का बना दिया.
Lowest generation development period.
Yeah. When operating cost is low, maintenance is low, maintenance is low. All these advantages. Next. Grid tied wind turbine. ये देखो grid tied कैसे बनाया है. This is the system. You can have a grid. You will have a controller. Why you need a controller? Because the wind generator is this, or windmill we call it. Then it goes to the controller. Why do you want to control it?
So wind is intermittent.
Intermittent.
So that is why we are required to
So
maintain.
it is maximum. The problem is of frequency. So have the frequency and then get connected to grid. I have seen in Gujarat all wind grid connected. I don't know whether other states have. Tamil Nadu probably have done it, but Gujarat में बहुत अच्छा किया. Next. So the essential requirements for a wind are the high wind. Farm में क्या चाहिए? High wind, of course. Then adequate land. Suitable terrain must be suitable. Then maintenance, then techno-economic selection of specific turbines, perpendicular prepared layout, etc. Okay. Hybrid power generation, little bit of hybrid. As I said, what are the hybrid systems? Solar. You have solar. You have wind. You have fuel cell, and you have batteries also. So that is the latest, and they are doing a lot of experiments. He is doing a research. She is also doing a research in this.
So in Aurangabad Government College, they have procured that all the equipments and formulated a lab under.
Same thing they have done. You can see here.
They have in total 5 sources have they have, including the MSCB, the Maharashtra State Electricity
अच्छा
Board supply.
अच्छा वो भी कर दिया.
The all admissions of Maharashtra DT students has been conducted in that place because it's always.
Okay, very nice. I think we'll stop here because
Yes.
the time is also over. आप थोड़ा connect करेंगे उन लोगों को? Yesterday she didn't connect them. Are there any questions? They don't speak.
So if you have any doubts, you can just ask sir. Those who have doubts you can ask. Because sir is a very experienced person and you can get good guidance from him. So I think like if you have any doubts, you can just clear it with sir. any research doubts also, because around 17, 18 students are doing PhD under sir on all these hybrid systems. Yes, sir. So those who have any doubts, like if you want to ask something, you can ask sir, because sir has I think more than 35 years experience in this field. 42 years, sorry, it is 42 years. 42 years of experience, and around now at present around 18 students are doing PhD under him. So like sir is a knowledge hub, you can say. So you don't get people like
Wikipedia.
yeah, he's like a Wikipedia, rightly said by one of the participants here.
If they want to know anything, my emails are
Yeah, sir's email ID is also there. You can ask. So I really thank sir, because I kept 2 lectures, because I know sir is like mainly into this field of energy management, and sir had done lot of research in this area, and seeing his PhD students itself, like we know he's having a very great knowledge in this area. So those who want to gain more knowledge, you can just contact him. And for the coordinators of various centers, I just would like to announce that I have sent the new timetable, because there was small changes in the timetable. I have sent you people, so please circulate among the participants. And the next session, it will start sharply at 11:30. So now we'll just break for a tea. If you have any doubts, you can ask.
Hello.
Hello.
Yes.
Can I ask a question, please?
Yeah, yes.
I was good morning, sir. I was just asking you, what is the production of solar? Means what is the future production of solar? Means what is going on in solar according to the production?
Solar is a very important non-conventional area which India is doing a lot of work, especially in states like Rajasthan, Gujarat, Tamil Nadu. These people are doing a lot of work in solar, but it is only in the field of PV generation. The thermal generation is yet to come up. The thermal generation efficiency is not very high. PV generation efficiency has now gone up to 25%, and people are claiming that it can go up to 40%. So, our city, Chandigarh, has been declared a solar city, and megawatt plants are coming here. And I think in Rajasthan there are many places where a lot of solar generation is taking place. It's a good future. It is one of the most important solar. I mean, this renewable energy source.
Around 5,000 megawatts.
Yeah, 5,000. More than 5,000 megawatts are already there.
Hello, sir. May I ask one question, sir?
Yes.
Good morning. Good morning, sir.
Morning.
Sir, my question is this, sir. Can you, sir, explain please hybrid system cabinet?
Yeah, hybrid
System cabinet.
Hello.
Can you explain hybrid system cabinet?
Cabinet.
The cabinet. Hybrid system is that system wherein you are actually mixing. You are mixing more than 2 technologies, more than 1 technology. So solar is there, wind is there, then fuel cell is there, battery is also there. If you have one place and they are all connected together, and you can have a system by which you can timely put on or off the system, which is at the highest potential, you can put it on, and the rest can be done accordingly. So there can be a schedule also. So that is probably the cabinet what you are saying, because it goes to the gallery. Actually gallery में जाता है power. वहाँ से power को आगे भेजते हैं. So you have the actually schedule कि किसमें हम कितना power generate करेंगे. Actually it is a trading actually. So when you have to trade, you have different this thing rates for that. Solar will cost you this, wind will cost you this, fuel cell will cost you this. Accordingly, and the demand of the state, you can have a schedule, and that is the hybrid system. And probably mixture is known as the cabinet.
Thank you, sir.
Excuse me, ma'am. DIT University has a doubt.
DIT. Yes, sir.
Yes.
Sir, solar cell is a current source or voltage source?
Solar cell. Solar cell is it? It is a voltage source actually.
It depends upon अगर आप सीरीज में कनेक्ट करो तो वोल्टेज अगर आप
नहीं वो तो कनेक्शन की बात है. It is a voltage source. It is a voltage source. Yeah, it is a voltage source. Because you generate voltage and then the voltage generated is very less, so you have to have the combinations. It is a voltage source.
Gives a constant like voltage,
Voltage
current
constant.
source. Voltage based on whether it is
It is-
constant or current is constant or voltage is constant.
It's this constant voltage ही आता है. Millivolt में देता है.
Sir, why it is represented by current source and diode?
The voltage actually it produces voltage. No doubt it produces voltage, but the current remains constant, and the controller is such that the current remains constant. That's why it is represented as a current source.
Thank you, sir.
Okay, thank you. Hello.
Yes, yes. Yes, yes,
Yes.
yes.
Good morning, sir.
Good morning.
Maharashtra. I want to ask one question, sir.
Yes, please.
In our Marathwada, we are facing scarcity. So now I want to know that which type of energy, renewable energy, is suitable for our region. Because it is totally dry region.
Dry region.
Solar or wind.
You are in a very dry region, so naturally solar will be utilized. Most utilized energy will be solar. So going for solar.
So what? How to develop the awareness among the people?
Yeah, solar, as I said, I have already said this, that solar efficiency is not very high, but people have very efficiently got PV production, not the thermal generation. PV production is on, and in Maharashtra and in Rajasthan also, a lot of solar units have come up. So you may go for solar generation.
One more question, sir. हमारे पास एक थर्मल पावर स्टेशन है जो टोटली बंद है पानी की वजह से.
पानी की वजह से?
हाँ, टोटली बंद है, पूरा इसका पैडल है. What?
बंद है, पानी की वजह से बंद है मीन्स क्या? कैचमेंट एरिया नहीं है. वाटर तो आपको मतलब बॉयलर में ही चाहिए, और तो कुछ नहीं चाहिए. बॉयलर में चाहिए ना वाटर तो आपको.
पानी because of scarcity of water.
हाँ, कूलिंग प्लांट्स में लगता है. तो पानी बिल्कुल ही नहीं है, फिर तो आप कुछ नहीं कर सकते. There is no water.
नहीं, the question is not clear, sir. आपका voice clear नहीं आ रहा है. एक और बार पूछो.
नहीं, पानी नहीं है.
What is the alternate?
Alternate.
Alternate क्या हो सकता है? Cooling some, I mean, water is required.
New technology without water.
Without water you cannot, because it is a thermal generation. It is a steam generating unit, isn't it? Your unit, it is a turbine, is steam turbine. तो आपका जो टरबाइन है वो स्टीम टरबाइन है. स्टीम टरबाइन नहीं चाहिए आपको. अगर पानी बिल्कुल ही नहीं है तो स्टीम नहीं जनरेट कर सकते. हाँ, अगर आपको कोयला नहीं है तो न्यूक्लियर में जा सकते हैं. लेकिन पानी नहीं है तो स्टीम तो आपका जो जनरेटिंग यूनिट है वो काम नहीं करेगा. You need to have water.
Near about 1,000 megawatt.
1000 megawatt की प्लांट है, but it is like because of
वो आपको फिर और कोई चीज यूज करना होगा. वाटर बिना नहीं हो सकता है. थर्मल जनरेशन में आपको स्टीम की चाहिए ना, बिना स्टीम के नहीं कर सकते.
So may I ask something?
yeah.
Hello.
Yes.
Sir, what may be the best mode of storing the intermittent energy?
Intermittent
energy. What do you mean by that? Intermittent
Storage of energy, sir. That he's asking.
Storage of energy is the
Battery.
capacitor best है, but it is lot of research is still taking it. It is only the storage is only through capacitor. If it is electrical energy.
intermediate.
And battery is also kind of storage. आप बैटरी को चार्ज कर लीजिए, कैपेसिटर को भी चार्ज कर सकते हैं.
So if it is intermittent, mostly capacitor.
Capacitor. हाँ प्रीति मैं अभी क्लास में हूँ मैं आ रहा हूँ
Okay, do you like? Is there any more doubts? Otherwise, we are just concluding it. We'll again reassemble after 15 minutes after a short break, tea break. So your participants here also can just have your tea.
11:30 हो गए ना इसलिए रिमाइंड करो
A very good afternoon to one and all. So we have with us Dr. Poonam Sayal. She is the Associate Professor here in the Electrical Engineering Department, and she is an expert in this area of renewable energy. She has done a lot of work on solar photovoltaic, solar thermal, and she has set up here. We have a 50 kilowatt plant, which was like the initiative was taken by her, and she had set up the lab, the whole setup. And apart from that, she had worked also in biomass and I think many other things. She'll be just giving an intro, and she has number of papers to her credit in national and international journal, and I think she's an apt person to give you more insight on biomass utilization and for energy generation. So I just hand over the session to Dr. Poonam Sayal. She'll be handling.
Thank you so much, Shimi. So good morning everyone at all the centers, nodal centers, as well as the participants at our institute in the ETV studio. As Shimi ma'am has told, I am going to talk about the utilization of one of the important renewable energy source, that is biomass. And as ma'am has told that I have done some work in with regard to solar energy also. So I just to continue where she just left, is that we have installed a 50 kilowatt solar PV power plant, which is grid interactive, and it is giving very good results. I just want to share this experience apart from the biomass utilization with you initially now, because we have felt that there is hardly any maintenance required for such grid interactive type of solar PV power plants, and we will encourage, rather propagate such type of technology that you can also install in your institute, because it is a green technology. And we also have the subsidy on the installation of such power plants. At present, the subsidy is around 30% on the total utilization installation charges of the solar PV power plants. And if you will go in for this, then the thumb rule is the cost of the power plant is around 1 lakh per kilowatt, and the subsidy is 30% when it is grid interactive. And when we will go in for solar PV type of solar plant, which is battery based, battery backup, then the cost is around 1.5 times that of our grid interactive simple solar PV power plant. So it has really gave us a very promising results, and that is why I'm sharing this experience with you. And we are also in the process of installing solar steam concentrating based cooking system in our mess, and that will also be the state of the art, and let it come up. And I'm sure that you would like to come here at our institute also and attend the various short-term courses, where you will be actually able to observe see all the implementation of such type of renewable energy sources at our institute and also at the areas nearby. So I'll welcome you all once again in this session, and now I'm going to talk about the biomass utilization. Our other colleagues might have told you the importance of the renewable energy sources utilization, and why they are most important is that they are the green technologies. They do not cause the environmental degradation, pollution, or other adverse effect to our environment and ecology, which is the very prime factor. Although another factor which involves the utilization of the various type of renewable energy sources is that our conventional energy sources, that is like fossil fuel, they are depleting fast. But nowadays the scene is a little bit different. If you have if you regard the prices of the oil, though they are quite falling down, and so there is you can say that some scope that we will be able to utilize the fossil fuels for a longer time as predicted earlier, but still the fossil fuels are limited in nature, no doubt about that, and there is very much requirement to use the alternate renewable energy sources which really are green technology and which contributes towards the sustainable development for the betterment of our future generations. Now, why the biomass is known as renewable energy source? The main thing is that it is a carbon neutral source, because the quantity of the carbon which is released when either we do combustion or when our biomass matter is decomposed naturally. They release the same amount of carbon dioxide in the atmosphere as they take in from the atmosphere during their growth. So that is why it is known as renewable energy source. Now, basically, biomass is an organic matter, and it is derived from the living organisms like plant and animal matter, and we have a different type of resources from which it can be derived, and it is one of the promising source of all the renewable energy sources which are available here. Although the topmost renewable energy source which is abundantly available in our country is solar, but the exploitation of that sources till date is not much, according to Ministry of New and Renewable Energy Sources, which has been established to propagate and disseminate and encourage the usage of renewable energy sources. They have analyzed the data of how much we have utilized or the various renewable sources. Then the solar energy is quite on the lower side, around 2% of the total potential has been utilized so far, while we have as compared to other energy sources, and the wind is has been exploited to the largest extent as compared to other sources. We are fifth largest producer of wind power in the world, and if we see the total picture of all the renewable energy sources, like from the biomass, from the wind energy, from the solar, and from the mini hydro, then we have just tapped around 13% of our total resources to generate the power as compared to our conventional energy sources, that is like coal is there, oil or gas is there. So the input from the renewable energy sources is 13% when we talk about the power generation. And since we have a lot of potential in our country, we have a lot of renewable energy sources, and the order is around 2 lakh for around 50,000 megawatt, and that is why the government of India has also set up a target to achieve more energy power from these renewable energy in our country, and the target is producing 41,400 megawatt by the coming few years. So one of the more important renewable energy source is the biomass. It is a biological produced matter which is based on hydrogen, carbon and oxygen, and it is basically derived from various sources which you might be knowing, like wood is one of the source, agricultural crops are there, raw material from the forest, major parts of the household waste, and byproducts from the timber industry. Now, why it is known as a renewable energy, and it is a biodegradable matter, and because the bioenergy is basically depends upon the process of the photosynthesis, whereby solar energy is used to take the carbon dioxide from the air and convert it into the energy rich carbon compounds, and subsequently these initial products, if they can be converted into another energy rich forms. And this is also you can biodegradable as compared to non-biodegradable type of our matter. So you might be knowing that biodegradable is that which decomposes easily, naturally, as compared to non-biodegradable resources like materials like metal is there, plastic or glass is there. So so that is the important other characteristic of our biomass material. Now, we have a lot of biomass potential in our country, as you can see, and the states which are having highest biomass potential in our country is Maharashtra, and that is of the order of around 2,000 megawatt. Madhya Pradesh is having around 1,400 megawatts. Uttar Pradesh is 1,600 megawatts. And Karnataka is having 1,100 and so megawatt and so on. Even Kerala is also having a lot of biomass. It is more than 1,000 megawatt. So keeping into the view of these potential of the renewable resources in our country, we can convert it into the useful form of energy, which can be directly used to meet our energy demands. Now, this biomass can be tailored for the rural or urban environment and utilized in the domestic, commercial, or industrial applications. The major processes which are used to convert biomass into useful energies, one is thermal conversion, that is directly it is converted or burnt to produce heat energy. Another is biochemical conversion. The biochemical conversion, it involves microorganisms or enzymes which helps in fermentation or further decomposition of the biomass. In the thermal conversion, we have basically three main categories of the conversion process. One is direct combustion, where it is burned directly. Another is gasification and pyrolysis, which is used to produce the solid, liquid, or gaseous biofuels through various processes. And in the biochemical conversion, we have anaerobic digestion, where in the absence of air, the decomposition of biomass takes place, and then it is a fermentation where we have enzymes or certain specific process through which the biomass is converted into liquid or gaseous biofuel to produce heat or to power the engine. When we think about the thermal processes of energy conversion of biomass, then traditionally what is being done is we burn biomass to create heat. Like in the villages, still more than 80% of the rural households, they depend upon the traditional biomass fuels for meeting their cooking energy demands. This is as per 2011 census. Just see, very few percentage of households have access to the LPG or other cooking resources. So, but the problem is the very low efficiency. As you can see, it is just 5 to 15%. And another is the smoke, emission of smoke from direct burning of this thing, which is very much harmful to the for the women who are cooking in the kitchen, and they face lot of problem with regard to it, and that is why they suffer from diseases like asthma or other lung related diseases. So it is very important that we use it in an efficient way, and that is why the technology has come, that is smokeless chulha, where there is a chimney which is provided with the chulha, so that when we burn the biomass, the smoke goes out from the chimney outside in the environment, rather than it just coming into the kitchen, and we have lot of problems related to health of the women who are exposed to such a large quantity of smoke throughout the day. So generally what is being done, it is used directly for heating, cooking and industrial processes, or indirectly to generate electricity, as we know in the power stations. And at biomass power plants, biomass is burnt in the boiler to produce high pressure steam, which in turn drives a turbine to generate electricity. Here the conversion efficiencies are low, this is just 20 to 40%. Another process of utilization of biomass into energy is the pyrolysis. So it is the oldest method whereby we produce the charcoal. Here biomass is heated in nearly the absence of oxygen. Very small quantity of oxygen is present, and it is heated at quite high temperature at around 200 to 300 degrees Celsius. And it produces, due to this process, it is decomposed and it produces a dark liquid called pyrolysis oil, a gas which is syngas, and a solid residue which is called biochar. Charcoal is almost pure carbon with about twice the energy density of original wood, and it is easy to transport and store this product as compared to our biomass. Here minimum 5 tons of wood is required for production of around a ton of charcoal. Another process for conversion of biomass to give us the useful energy, it is known as densification. It is also a physical process. One is a production of the production of pellets and briquettes. Now the briquetting process, it includes the process of compacting the loose biomass into a uniform dense form. So this can be done by putting on the pressure on the biomass in a special machines which is known as briquetting machine, and sometimes we also add a little other material compound so that we get a better form of our briquettes. Here the biomass which can be used, which is suitable for densification, should have relatively low moisture content. It should be less than 15%, which is available in the biomass resources like stalks, husks, bark, straw, shells, pits, seeds, and sawdust, etc. So as compared to loose biomass, it is a better quality fuel, which is easier to transport, store, and easier to handle also. Another process of densification, it is known as torrefaction. It produces pellets through high temperature oxygen removal process, which is similar of making the charcoal. It is a mild pyrolysis process where partial decomposition of biomass takes place and solid biomass is torrefied. Now this biomass is also heated at around 200 to 320 degrees Celsius. It loses 20% of its original mass but retains 90% of its energy. So it has 30% higher heat content in comparison with the original biomass. Another important characteristic of the pellet is that it is hydrophobic, that it does not absorb moisture from air, and it has a good potential for usage in the coal power stations. Now another process by which we use the biomass, that is biochemical. For the production of biogas, bacteria is used which breaks down the biomass, and as a byproduct methane is produced, which is a clean fuel resource for generating heat and power. Now biofuel, it is primarily derived from sugarcane, maize, beets and other starchy crops. It is produced due to fermentation. Here simple sugars are converted to alcohol and carbon dioxide. Here the bacteria is added and yeasts and enzymes produce biomass liquids which cause biomass materials to ferment and change into alcohol. Similar process is used to turn agricultural products into ethanol. Now ethanol is, as you might be knowing, it is a colorless liquid, and it is mixed with the gasoline to make an ethanol gasoline blend fuel for running up our engines, or for even for using it as our transport in the transport sector. Like up to 85% of ethanol and 15% of the petrol is successfully being used in various transport vehicles in USA, Sweden and Brazil. Here in the Brazil, even 100% of the ethanol has been used for running the vehicles. So it is also a very promising technology. Now thermochemical process is the process where where the biomass reactors, they heat the biomass in the low oxygen environment and produce the producer gas. This gas basically have a carbon monoxide, hydrogen and methane. The energy of content of this producer gas is 1/10 of the natural gas. It can fuel steam generators, combustion turbines and combined cycle technologies. It is good for running internal combustion engines. Here you can see the picture of the biomass gasifier. So basically it is a reactor. It is a closed reactor which converts biomass into clean gaseous fuel by heating the biomass in the limited oxygen, where the solid biomass, it breaks down to form a flammable gas which is called a producer gas, which is having a calorific value of around 1000 to 1200 kilocalories per cubic meter, and it consists of carbon monoxide, hydrogen, carbon dioxide, methane and nitrogen. The producer gas, it is fed into the diesel engine and to let the engine operate in the dual fuel mode. thereby reducing the diesel consumption by more than 70%. Here initially the engine is started with the diesel, and later on after a few minutes we induct the our producer gas slowly, and initially we just let it consecutively, in consecutive steps we increase the output of this our producer gas, and we decrease the diesel inlet to the inlet of the engine. So up to 70% of the diesel can be saved when we use this, and it has been found quite successful in the industries, the usage of this gasifiers. And there are very good case studies, especially in the southern region, in the industries where this renewable energy source is being used to generate power. Now this can be directly burned in the furnace also to generate the process heat. The moisture content of the material which should be used for generating the power in the biomass gasifier, it should be less than 20%. And generally this type of fuel is firewood, coconut shell, corn flour stem, sawdust, rice husk, and cotton stalks. And using gasifier, 1 liter of oil can be saved through use of either around 4 kg of wood or about 5 kg of rice husk. And the payback periods is 2000 to 5000 hours of operation depending on the capacity of the gasifier. And 1 kilogram of biomass, it produces around 2.5 to 3 cubic meter of the gas. I have visited to some of the industries in the northern side of our country, and I have seen that in the industries, I was talking with one of the experts in our Punjab region. Now here the problem is that the type of biomass waste which we receive is mostly in the form of husk or sawdust, and it is very difficult to the handling of this type of material. This is one of the major problem which they are facing, and they told me that. So thereby here in northern region the technology has not shown that much promising utilization effectively in the field as compared in the south, where they have a very good material like coconut shell, which is quite easy to handle when we compare to our rice husk and other type of material. This is one of the, you can say, hindering factor for propagation of this technology in the northern region. Maybe some research or projects can be taken to deal with this problem by the students also. To generate 1 kilowatt hour of power, we require around 1.5 kg of wood in the biomass gasifier, and the power generation for industry through diesel generator set, which operates on the dual fuel mode, is found very much successful in textile mills, dyeing and processing units, foundries, tea factories, coir industries, rice mills, etc. It is also found effective for heating in tea, coffee, drying and processing units, food processing, tile making, rubber and oil processing units, cooking, etc. And also it is very successful for the electrification of rural and remote areas where we don't have electricity supply, and also for irrigation pumping. Like if you see and various or interact with the persons who are working in this area, or you see through the internet various sites, you will see that certain non-government organizations, they are doing very good work by installing renewable energy sources in the rural remote areas where still they have lack of electricity. Either it has not been transmitted to that particular area because it is a hilly terrain, or other some problem is there. They are installing successfully solar photovoltaic power generation plant, or where the area like in the remote areas of UP or Bihar, where these NGOs are doing wonderful work and they have using biomass gasifiers for giving the energy to the rural areas, which is very much required for the development of any area, as we know. So this is these are another things in which we can see the promising future, that is for electrification of the Now, when we talk about the production of biogas, which is generally being produced by fermentation of cow dung, that is the cattle, you can say, waste. You see, we are in this way, we have got a very good potential to use this resource, which is otherwise not being that effectively utilized by the traditional way, because of our country, we have the largest livestock population in the world. Right, we are more than 480 millions of cattle in our country, and India ranks first in cattle and buffalo population, second in goat population, third in sheep, and seventh in the poultry population when we compare it with the world status. So, and biogas, the main resource used is the dung of the cattle. So we have a lot of promising, you can say, area to use this resource for our energy needs. Like you see, traditionally what is being done, we have a cattle dung, right? We make cattle dung cake and then they are burnt. But the problem is that there the efficiency of cattle dung burning is around 11% or so, 11 to 13%. While when we allow the cow dung or cattle dung to ferment in the closed digester in the absence of air, that is through biogas technology, then we get gas also, which is methane gas mainly, which have around 40 to 60% is the methane gas in the biogas generated, and also we have digested slurry, that is the gas we get, and in addition to that we get a organic manure, which is very much required for our country, because we are most of the persons are really, working in the agriculture sector in the rural areas, farmers. So it is having you can say twin benefit. One is it can be used for cooking when we allow to use the biogas technology, and another it is very good for the organic as a more organic manure source also. So we have a lot of potential, and since we have 500 million poultry birds around and 280 million of bovine animals in our country, and it gives a very efficient fuel for cooking, lighting, and helps to generate motive power. It gives good organic manure also, which is very much rich in the nitrogen, humus, and other micronutrients, which is lacking in our chemical fertilizers, the micronutrients, and that is why our soil health is also adversely being affected when we are using our fertilizers, chemicals. So it is very much required, and we should encourage and make aware the farmers and all the persons who are engaged in the agriculture related activities that such type of organic manure should be promoted to be utilized in our fields. Now the digested slurry, it can be used for manuring the crops, and the application of such organic manure, it reduces the salinity or alkalinity of the soil and increases the porosity and water holding capacity, thereby increase for the betterment of the soil health. This digested slurry is applied at the rate of 10 tons per hectare for irrigated land and at the rate of 5 tons per hectare for the dry farming, and it has been seen by applying this organic manure as compared to our chemical fertilizer that the yield has grown up by 20% over the years. Immediately you won't find the results will be that encouraging, but over the years they will improve. And another thing is, when we talk of manure application, is that it should be gradually replaced. It should gradually replace the chemical fertilizer. Like immediately if you propagate and tell the farmer that he should replace all the chemical fertilizer with the organic manure, then the yield of the crop will be less as he might be getting with the fertilizer application. So you have to the application of the manure has to be taken in the steps. Like first time it may be 25% of the manure should be organic and the rest should be chemical, and the next cycle we can add 10 to 20% more, and gradually we should increase the application of organic manure, and the chemical manure can be reduced later on in gradual steps. So that will give better crop yield to the farmers, and thereby they will not lose their incomes also. So now one of the major aspect of the biogas generation is fermentation, through the enzymes or microorganisms which is anaerobic in nature, and that is in the absence of air they grow and thereby they ferment, and we get a very good gas which is having the main constituents as methane, which ranges from 55 to 65%. Carbon dioxide is 20 to 40%, and we have impurities like hydrogen sulfide and nitrogen with small traces of water, 2 to 7%, some very minor percentage of oxygen, around 2%, and same with the case of nitrogen, and 1% of ammonia or even lesser than that, and hydrogen sulfide. When we see the properties of this biogas is lighter than air. It is around 20% lighter than the air, and the temperature, ignition temperature of this gas is around 650 to 750 degrees Celsius. It is an odorless and colorless gas, so it is just like when you actually see this, it will just appear you like you are burning the LPG gas, which is also having a clear blue flame. Only thing is that since its calorific value is lesser than the LPG, therefore the burners, the size of the holes in the burners are bigger as compared to our LPG based of chula. So calorific value is 20 megajoules per cubic meter. It burns with 60% efficiency in conventional biogas stove. And also the thing is that we should not use this. Although people have done in the field that they have used the same chula as being used with the LPG type, but what happens is it contains moisture also. So, and the calorific value is less, so they will have a lesser quantity of gas, and after sometimes they will find it difficult also because of the retention of moisture in the pipes and also with the small holes through which we have the our gas. So it is recommended that the chulas which are specially designed for the biogas plants, they should be used, which will give better and output and for efficient cooking. The mainly if we see the equivalence of biogas as compared to other conventional energy sources, 1 cubic meter of biogas is equivalent to 0.52 liters of diesel. It is equivalent to 0.62 liters of kerosene, 3.50 kg of wood, 12.30 kg of kettle dung cake, 0.43 kg of LPG, and 1.46 kg of kilogram of coal. And when we see the nutrient content of this, the slurry which we get from the biogas plant, that is known as digestive slurry, as compared to simple organic manure, that is farmyard manure, where what do the farmers do? They dig a pit, put the material, the organic waste inside it, and just cover it up with the mud, and after 6 months they are able to get the manure. But still this organic manure is having higher content of nutrients as compared to that organic manure. Like here the nitrogen content is around 1.5 to 2% as compared to farmyard manure, which is 0.5 to 1%. Phosphorus and potash is 1% as compared to 0.5 to 0.8%, which is contained in the farmyard manure. So it is better than that also. And the main sources which are used for generation of biogas include excreta of cattle, piggery waste, poultry droppings, algae, crop residues, paper waste, human waste, garbage kitchen waste. Now it has been found the best usage, the enzymes which they use to convert our biomass waste into the biogas, that is the cattle dung. Although, so what is being recommended is that there should always be some quantity of cattle dung, and it can be mixed with other type of waste to give us the efficient biogas production. There are 3 phases of anaerobic digestion. The first one is enzymatic hydrolysis. Here hydrolytic bacteria, it acts upon the our cattle waste, and fat, starches and proteins, they are broken into simple compounds like fatty acids, alcohol, carbon dioxide, hydrogen, ammonia, sulfides. In the acid formation, acidogenic bacteria acts and it converts the simple compounds which are obtained from the enzymatic hydrolysis process into acids, mainly acetic acid, hydrogen and carbon dioxide, and volatile solids. In the last stage, the methanogenic bacteria, they act for methane formation, Here the organic acids which are obtained from the acid formation stage, they are converted into methane and carbon dioxide. And this is obtained by using mainly two types of biogas plants. One is floating gas holder type, which is also known as KVIC type. And you might be knowing KVIC is a short form of Khadi Village Industry Commission, because a person who really made up and he invented this technology, the design of this technology, it was related to KVIC. And another is the fixed dome, that is the Deen Bandhu type. Where AFRO, the person from the AFRO, it worked upon it, and thereby the design was evolved. In this type of biogas plant, we have we mix dung and water in 1:1 ratio. Generally, what happens is the farmers, they put 1 bucket of water and mix 1 bucket of cattle dung in it in the inlet, and thereby it is mixed and then it is fed into the digester. You can see the cross-sectional diagram of the KVIC model of biogas plant. Here we have a digester, and you can see lower side, that is brick masonry structure is there, that is known as digester, where decomposition of the our waste takes place. On the left side there is a mixing pit. That is the inlet tank where we mix water and cow dung with the stirrer, and then it is fed into digester. After say 30 to 40 to 50 days, depending upon the climatic conditions of the particular area, the gas is decomposed, the matter is decomposed, and it is acted upon the various enzymes as we have discussed earlier, and we get the biogas, which is lighter than air. It is filled up on the topmost container, or it is also known as gas collector chamber, or it is generally made up of mild steel. And then the digested slurry, due to gravity, because the digested slurry is having lesser density, it is decomposed, no? So it is lesser in weight as compared to our cow dung, fresh cow dung, which is fed, or cattle dung, which is fed into the digested plant. So it automatically rises up, and it is we have the outlet of the for the digested slurry on the right side. And just see one more point is that the inlet point should be a little bit higher as compared to the outlet point, right? This is the one of the design factor. Another is that you are seeing in between the digester chamber there is a partition wall, right? This partition wall is made so that there should not be short circuiting of the raw material. That is, if the capacity of the biogas plant is more than 6 cubic meter, this partition wall is made so that what happens is without fermentation or without decomposition, this the input material, it should not directly go out without producing the gas. So for retaining it for a longer time and getting it fermented in a proper way, the movement, to increase the movement time, as you can see, first it will go to first chamber, then it will rise up, and then from the top wall it will move down to the outlet chamber thereby. So it will take a longer time and better fermentation will take place. So that is why it is an important part that partition wall should be built up for more than 6 cubic meter of the capacity. And when we, if you'll go and have a look, then it will, the KVIC model type will look as you have seen. You can see in the picture. This is how it will appear to you when we see the biogas plant. Here you can see the black color top, this container, it is known as gas digester, and the white color below the ground, that is the construction, that constructed part, it is, which is not, you can see from here, that is the digested chamber, digester, or you can say. On the right side, if you will see, there is a stirrer, there is a handle, and this is the mixing tank, the inlet chamber is there, right? So this is about the KVIC type. Hanji. Hanji? Outlet is on the back side, so that is why it is not appear in the picture. It is just opposite to it. And generally, what happens is then when from the outlet, in the layers fashion, like first layer is of the slowly biodegradable material like leaves or hay stalks, something they are put in 1 to 2 inch thick on the pit. Over that, a small, say 2 to 3 inch thick layer of this slurry is put, and thereby alternately we put in the various type of biodegradable materials along with this manure, and this is kept for some time, and after that this slurry this can be taken out and it can be used for our agriculture purpose, or directly digested slurry can also be used if it is nearby the field. Now what happens is sometimes the field is away from the kitchen, that is the source of cook where we want to use the gas. It should not be far away from the kitchen, no, otherwise how can we supply the gas? Sometimes the fields are far away, so what they do is they let it dry for some time and then they collect it, the manure, and then they apply in the fields. This is another way of utilizing the manure. Now the another popular type of biogas plant, that is Deen Bandhu biogas plant. Here it is all underground. It is underground brick masonry structure with dome at the top for the gas storage, and it is specially, you can say, it has a concave bottom and it is a spherical type, right? Why is it is so? Because for the same volume the surface area is less, so less material will be used, lesser will be the cost. Its efficiency, the cost is around 40% less as compared to KVAC type, because in the KVAC we have a metal dome, so that adds to the cost. And another thing is that the dome, because the moisture also comes out, so what happens is the dome, it has to be repainted after few years, and after say after 1 year or 2 years, because of the moisture to corrosion, to prevent the corrosion, and after its life is limited to 10 years or so, then it has to be replaced also, the dome. So that is why this is about the piche wala, this one, the last one. About the KVAC plant, if I discuss, you see this, the gas collection chamber, no, it is made of a mild steel, and there is a moisture also, because we put 1:1 ratio water and kettle dung. So जब हमारी गैस मूव करती है ऊपर, तो साथ में मॉइस्चर भी थोड़ा बहुत इवेपोरेट होता ही है, राइट, है ना? एंड इट इज, यू सी, इट इज, इसको ब्लैक कलर से पेंट किया हुआ है. व्हाई? सो दैट it collects the heat from the sunlight, because 35 degrees Celsius is the optimum temperature for generation of the biogas. Maximum generation is around 35 to 38 degrees Celsius, and when the temperature goes down, the production also gets decreased, and that is why in winters it always produces lesser biogas as compared to summer. So the enzymes act like that. But here you can see it is all underground, so that we get the thermal insulation and good heat, and it is all masonry structure. That is why its cost is less as compared to our KVAC type of biogas plant. Now the only thing is, here we have more than 100 cubic meter capacity of the plants can be constructed when we talk about the KVAC type, but for the this Deen Bandhu type, we have less than 10 cubic meter of the biogas or standard designs are available, which I'll be discussing with you in the coming slides. And you can see how we require a skilled manpower, the skilled technical manpower, because you can see it is a spherical in structure, right? And there should be no leakage from the walls of this type of, it should be airtight, our digester and all the unit of the biogas plant. So we required a special technical manpower to construct it. And you can see how it looks from the outside. It's just a dome, you can see, and on the sides you can see the skilled labor working upon it to this thing. So it is recommended that if you want to construct the Deen Bandhu model of the biogas plant, you can approach to Khadi Village Industry Commission. They have the standard design as well as the skilled manpower, which have been trained by them. There are certain training programs for skilling them. And another is, you can approach the agriculture department, then Department of Science and Technology. So these, and agriculture universities also. Those persons, they are appropriate, so that you can get the technical know-how to install such type of plants. Another thing important I am coming to is the designing, that will come later on. Which is very much connected with the input required or the feed material required for the biogas generation. Now you can see in the slide that there is a particular amount of the feed material required for generation of 1 cubic meter of the biogas. Like cattle dung, if we are using, we require 25 kg per day per cubic meter. So larger the size, more quantity of cow dung is required. Then poultry manure 12 kg per day, pig manure 20 kg per day, human excreta 35 users per day. And if we see the gas production from the various types of dung, it also varies from the different types. Like for cattle, cows and buffaloes, the gas production per kg of dung in cubic meter is 0.023 to 0.040. For pig, it is more, that is 0.040 to 0.059. For poultry, it is even better as compared to the earlier type of our animals. Here it is from 0.065 to 0.116 of per cubic meter gas production. And human, it is, you can see, 0.020 to 0.028. Just you can say little bit lesser than the production of as produced from the cattle dung. Now it can be calculated that how much cattle dung will be available if we want to construct a biogas in a particular location. Like for the cow, for a single cow, it gives around 10 to 15 kg of dung in a day. Buffalo around 15 to 20 kg. Pig is 2.5 to 3.5 kg, and chicken 90 grams. Now the important part is the size. When we anybody wants to install the biogas plant, then the person should know what will be the usage of the biogas plant. Like if we have a capacity of 3 cubic meter and we have 5-6 kettle, then it can be used for cooking of the person's food for 7 to 8 persons. So depending upon the size of the family, one should think about the capacity which needs to be installed, and also the quantity of the cow dung available, because we need the raw material daily, which is shown in this slide. Like for 4 cubic meter plant, we require daily 100 kg of cow dung, and so the minimum number of kettles available to that particular household should be 7 to 8 in numbers, and it is sufficient to cook the food for around 10 members in a day. The biogas plants also vary size, and their special designs are available, standards designs are available. The smallest plant is 1 cubic meter per day capacity, and it produces around 35 cubic feet of gas per day. And but this is not generally propagated, and it is used for demonstration purpose only, because it is suitable for preparation of food for only one person. The other standard sizes which are available are 2, 3, 4, 6, 8, 10, 15, 25, 35, 45, 60, 85 and 140 cubic meter per day capacity. Now if the plant size is not much, it is around 1 cubic meter to 10 cubic meter, then these plants come under the family size plants. Whereas the plants which capacities varies from 15 cubic meter per day to 140 cubic per day, they are the largest sized plants. They are known as community size or community biogas plant, which caters to the need of the institutions or community centers. Now this classification is done mainly for the design part, and also because the subsidy pattern is also different of the government of India. There are usually the government also want to promote these renewable energy sources, and they provide the subsidy for installing of these plants. The subsidy now it varies from state to state also, so this has to be checked up with the state government, and also maybe there is a state renewable energy development agency in each of the state. Like in Punjab there is PEDA, Punjab Energy Development Agency. In Haryana there is HAREDA, Haryana Energy Development Agency, and similarly in UP it is NEDA, and so on. So if the person is interested, then it is advisable that the person can contact the respective energy development agency, and he will come or she will come to know what is the subsidy pattern and take the advantage of it also. And another thing is, when we talk of the size limitation, the Teen Bandhu type, it is up to 6 cubic meter capacity the design is available. While KVIC type, it can be the capacity can be built up to 140 cubic meter of the biogas plant. Now the difference is is due to the masonry structure, right? There is no the metal that like is not just bricks and our cement and that is involved. कोई इसमें iron का या कोई वो role हम use नहीं करते because of the cost factor, and that is why उसकी strength इतनी ही bear कर सकता है वो, इससे ज़्यादा capacity की it cannot bear that masonry structure, right? That is why there is a limitation of the size when we talk about the Deenbandhu plant as compared to KVAC type. And because of the lower cost factor, the Deenbandhu type is the most popular biogas plant across our country. Now, as I've just discussed with you earlier, that the optimum temperature for the generation of the biogas is at 35 to 38 degrees Celsius. So, depending upon the climatic condition of a particular region, we have a different retention point times. That is how much time it will take to generate the gas. Like in the coastal areas, which is Karnataka, Andhra Pradesh, Tamil Nadu, Goa, Maharashtra, Kerala, etc., the retention time is just 30 days. After 30 days, we'll have full generation of gas. While in the moderate areas like Gujarat, Haryana, Punjab, Bihar, Uttar Pradesh, Madhya Pradesh, Rajasthan, West Bengal, where there is the retention time is 40 days. However, in the hilly areas where temperature is quite less as compared to coastal and moderate areas, where the temperature here the retention time is much more. It is 55 days to generate the biogas, like in the areas of Himachal Pradesh, Sikkim, Kashmir, and hills of Uttarakhand. Now, the biogas can be utilized for lighting purpose also, for dual fuel engine also, or for electricity generation also. For different purpose, different amount of biogas is required. Like cooking, if we have a different size of burners are available, like for 2-inch burner, we require 0.33 cubic meter per hour. For 6-inch burner, it is 0.64 cubic meter per hour of the biogas. And per person per day cooking, the gas requirement is 0.24 cubic meter per day. For lighting a lamp, for 100 candle per hour, we require 0.13 cubic meter per hour. But it has been found that this technology utilization is not much efficient as compared to other utilization of this resource, that is for cooking or for running dual fuel engine. For dual fuel engine, fuel engine, where we can replace the diesel oil per horsepower of the order of 70 to 80%, we require 0.50 cubic meter per hour, and almost similar quantity of biogas is required to generate electricity of 1 kilowatt hour. And even small IC engines with generators can be used to produce electricity by using the biogas plant in the rural and remote areas, which have been found quite successful. You see, the biogas generation also depends upon certain factors, because microorganisms, that is living microorganisms, are working upon the waste to give us the generation of the biogas. And these organisms, they can survive and optimally do their work in certain conditions. Some of the important conditions are that one is the pH or hydrogen ion concentration. It should be neutral, like 6.5 to 7.5, as we liked in our water also. You can see generally the range of drinking water potable also, we want that pH should be neutral, right? And here the microorganism, they also want that it should be a neutral environment under which they would like to work. And the temperature optimum for maximum biogas generation is 35 to 38 degrees Celsius. And it should be noted that when the temperature falls down by 10 degrees, say around 20 degrees or so, then the production of biogas is half. And at 10 degrees Celsius, the production almost stops. So it should not be very low temperature. Then total solid contents, that is 8 to 10%. That is why we add 1:1 by ratio the quantity of water, because in the cattle dung we have 20% of the total solid content. So to make it 10%, we add equal quantity of water. Then carbon nitrogen ratio of input material is 30:1. Here nitrogen is required for fulfilling the protein requirements of the microorganisms, while carbon is required for building the cell structure. Another is the nutrients and uniform feeding, that is as they are living organisms, and we also have a certain time to eat food. Similarly, they also, if we feed them daily at the same time, then the generation of the biogas will be more as compared to if we irregularly feed them the cow dung to the biogas plant. Then another important is the mixing or stirring of the contents of generator so that all the microorganisms have access to the food. Another important point is there should not be any toxic substance which should be mixed in the cow dung, otherwise it will kill the microorganism and our biogas production can be stopped. Now another important factor related to the biogas is the selection of the site. That is, the distance between the plant and the site of the gas consumption should be less so that we have the efficient, you can say, transmission of our gas to the to our kitchen, and with, of course, with lesser cost also. So it has been found that for the plant of 2 cubic meter, the optimum distance is 10 meter. Another thing is that sunlight should fall on the plant because the temperature of 25 to 30 degrees Celsius is essential for gas generation at the good rate. And it should be minimum 15 meter from the wells or source of drinking water. It is very important. Why? Because the pathogenic bacteria, they are there in the kettle dam. Okay, if it is our source of water is nearby, then there might be a possibility of leakage of our waste into, and it will be ultimately mix up with the our source of the water, drinking water, and it will create the problem, health problems in the vicinity. So this is very important. You see, what happened was, it was especially this thing point should be taken into view. What happened there was a project in the northern India where some funding was provided to make it for the better sanitation and for the better utilization of dung rather than cooking with the just combusting the material. It was propagated that at each household of that particular village we should install the biogas plants. Then after some years, of course, we always, whenever the funds are given, the evaluation of the projects are always being done. So an independent agency was asked to evaluate what was the effect of the installation of biogas plant at the particular location. It was found that the health of the persons of that villages deteriorated rather than improving because of the better sanitation and cooking facilities also because of the installation of biogas plant. So the main cause which was found was that this particular point, that is minimum 15 meter distance from the wells or source of drinking of water, was not kept. Right, water source, and they were nearby. So what happened was, ultimately due to some reason, it was just percolated down, the pathogenic bacteria. It mixed with the source of the drinking water, and people were having lot of infections and other problems, diarrhea and water related diseases they were having, and their health deteriorated overall. So that is why it is very important when we design, or when technically any technology, it may be proven very much feasible in the labs, but when we want to install it at a particular size, we should see other factors also which are very important, like minimum distance and like sunlight should fall, all these things. These things are very important, and not in case of only this technology, but similarly in the case of other technologies also. There are certain specific conditions in the labs whereby we test the particular technology, their feasibility. But when the same type of environment is not provided in the field, then it is generally people say that technology is not feasible. But it may be because of the other parameters which we have to consider when we install a certain technology, whichever it might be. This is a very important factor. Then another thing is, it should be near to the cattle shed, because we should have the lesser efforts for handling of the cow dung and so. Then another is, area should be free from the roots of the trees which are likely to creep and cause the damage to the digester. You see, like in our houses also, we generally see that hamare chhat pe, in the roof or nearby our house, we should take into care that the trees should not be grown very near, because usse nahi to the roots they creep into and then they cross the cracks in the masonry structures. So here also these things should be kept into mind, because otherwise what happen, it will break, and or it will create the, you can say, crack the structure, and ultimately we will not have proper functioning of the biogas plant, and generation will also be adversely affected. Then sufficient space for operation and maintenance is required. It is recommended that we require 10 to 20 meter square area which is required per cubic meter of the gas. Another important factor with regard to the biogas is that it should be recharged or cleaned and then again charged after every 10 years. As I discussed that the optimum temperature for generation of the biogas is around 35 degrees, but in the winters it is not possible because the temperature of the environment is lesser as compared to the summer. So there are certain methods by which the biogas generation can be increased in winters also. One of the method is using warm water for dilution of dung. Another is that we dilute the dung slurry in the mixing tank and keep it all the way to warm up. Like by 3 o'clock, we'll see that the temperature of our input feed material, it will be warmer as compared to in the early morning. So then it can be fed. Then addition of organic matter containing high percentage of nitrogen like night soil, and also mixing of digested slurry because they have more microorganisms and thereby it will increase the biogas generation. Kitchen waste, green leaves, grass clippings, they can also be added after drying and mixing with the dung. Generally 1 kg of such biomass can be added daily with 100 kg of dung, and then it can be fed into the plant. Another options which is available is gas holder can be covered with a gunny bag or polythene sheets to provide insulation during nights, and the digested slurry of 2 liters can be added to 100 liters of fresh slurry to increase the bacterial population in digester. A tent of plastic sheet can be erected so that it can retain the heat on the floating gas type of plant, but here it will add the cost. The annual energy saving potential of the family size of biogas plant is 1680 kilowatt hour, while for community size it can save 37,500 of kilowatt hour as compared to our traditional energy sources. So we have a bright prospects of using this renewable energy source because we have lot of cattle population, so it is possible to establish more than 10 million biogas plants in our country, and if we install such capacities, such number of biogas plants in our country, it will provide energy to substitute commercial fuel, which is equivalent to 6.77 million liters of kerosene, which are valued more than rupees 34 million, and it will also help in producing the organic manure to the extent of 74 million tons, and thereby it will reduce the burden on the exchequer by preventing the usage of the fertilizers. The potential of the biogas plant in our country is 120 lakhs, but till now we have installed 48.2 lakhs of biogas plant, so we have lot of potential to further work upon this technology. The benefits of biogas include the large cattle population, which ensures the steady supply of raw material for running the biogas plant. We have over 240 million heads of cattle and buffalo, and which yields around 1,000 million tons of cattle waste annually. It helps in reducing the deforestation also because it arrests the cutting of trees for firewood for cooking purpose. It helps in maintaining the ecological balance because it do not produce any greenhouse gas emission, right? It helps in rural sanitation, and since you see it is colorless and odorless gas, and whenever it is fermented, there is no you can say no we have no flies or other things when it is properly fermented. So this also helps in providing the better environment. It has all low capital cost and almost cost-free maintenance, and it also saves the drudgery of women, which have to otherwise go outside and maybe more than 3 to 4 kilometers or maybe so to collect the wood and then to use it for the cooking purpose. For Deenbandhu construction, we have a standard designs which can be accessed through this website that you can later on see if you're interested or to guide someone. a case study with respect to the biomethanation power plant. I'm just saying that how it has really produced useful for power generation also. There is a plant which is in Ludhiana, and it is the plant design was made by the Germany company, which is Antec, and the capital expenses were 15 crore of rupees, and it was established in the year 2004. Here what happened was there was lot of dairies around, like this lot of population of cattle was available, and rather than just what happened previously, all the waste, it was just put into one of the source of, you can say, a small rivulet was flowing, that is the Buddha Nala. It was just put into that. It was creating a lot of problems, and rather than just wasting it, it was used to generate the renewable energy source. So it was installed with the help of Punjab Energy Development Agency. The installed capacity was 1.06 megawatt. Power generation capacity was 14.9 megawatt per day maximum, and feedstock thereby required was 235 tons per day. And it has a fermenter to digester, that is 5,000 cubic meter each. 2 fermenters were there. Biogas yield was around 10,000 cubic meter per day. And manure was also produced of the order of 15 tons per day. And because of it was working very successfully, so it was also received Best Green Power Plant in Asia by Asian Power in Bangkok. And it was analyzed that in the year 2012, it gave around 2,400 megawatt hour of energy and saved more than 2,000 tons of carbon dioxide equivalent carbon footprints. And it also generated, it was found 59.7 kilowatt hour per ton, that is 94%, which was highest yield in November 2012. So this slide shows the various potential as well as installed capacity of different type of renewable energy sources. And you see the biomass which has been used, it is around 11%, which has been utilized, the potential utilized. For small hydro it is 19%, for solar energy it is 2.65%, and wind it is more than 20%. Here the potential of biomass is more than 17,000 in terms of megawatt, while the installed capacity is around 2,000 megawatt. It is very much advantageous to utilize this biogas technology to improve to access of clean energy source, and it will balance the use of fossil fuels, which will save them for further application and future generations. It will reduce pollution and emissions from the conventional energy systems. It reduces the dependency and minimize the spending on imported fuels. It is very much suitable for small off-grid application, which is very effective and good for rural and remote areas where energy is very crucial for human development but not available. Such small energy, it can also contribute to the local economy and create local jobs. So thank you so much. This was regarding the utilization of biomass. Now the session is open for discussion and for question answer. So I'll request the participants from various centers to they can ask the questions or doubts. Yes, please.
Hello, good afternoon, ma'am.
Good afternoon.
I'm calling from MM University, Maulana Ambala, Hindu
Yes. Yes.
From biotechnology. Ma'am, I want to know about how we can convert this energy from the agriculture waste biomass, on how we save this energy. Agriculture waste biomass, how we save that energy is converted from the agriculture waste biomass. Is there any method?
Yeah, I just expressed it in my initial slides that biomass gasifier can be used for generation of power for meeting the needs of the industries or for producing the electricity at the remote areas.
Is there any other method also? Yeah, only gasification.
Commercially available, which is available, and that is gasification. But otherwise, you can go in for this pyrolysis also is there, like which I've already discussed. That is another generation than pellet and briquettes making, so that it can be used for combustion later on.
Ma'am, I want to know what parameter we can consider for biomass characterization. Is varying according to biomass, not some parameters.
Yeah.
Which
One
applies
is
to
calorific.
production of energy.
I think for that person I am from the electrical engineering background, and the person from the chemical engineering or from the chemistry background will be able to give you a better insight in such the way you are asking. Although one of the parameters I can say the calorific value, which is very important of the biomass when we want to convert it for another useful form of energy.
Energy. Okay. Thank you, ma'am.
Any other question, please? Okay, then thank you. We'll move to the next center. This is Gyan Jyoti. This is Beed, I think. Beed, Government Polytechnic, Beed, any questions? Yes, please.
Hello, madam. Thank you.
DIT Dehradun, questions regarding biomass utilization?
No, ma'am, we have no questions.
Okay. We'll move to next center.
Hello, good afternoon, ma'am.
Good afternoon.
Ma'am, my question is this. Can we store biomass, biogas in any cylinder?
Yeah, it can be stored, but at present, the work is being done because you see it is very expensive to separate the other gases. Like I told you, it has a traces of nitrogen and other gases also. Like water is there, moisture is there, nitrogen is there, ammonia is there, hydrogen sulfide is there. So it has to be separated before we store the methane, and it is very expensive. So that is the problem. Otherwise, it can be stored. So the research and development is taking place to evolve the cost-effective methods to separate out the impurities from the biogas plant.
It means we have to separate the methane gas before storage. Huh?
Yes. We have to separate the moisture and other impurities from the methane gas. Yeah.
Thank you, ma'am.
Hello, ma'am.
Hello.
Hello. Are you getting me?
Yes.
Good morning, ma'am.
Good morning. Which center is this?
Jaipur Engineering College and Research Center.
Hanji.
Ma'am, as you suggested that we should warm water in winter to increase the efficiency of biogas plant.
Yes.
As you suggested, we use warm water in winter to increase the efficiency of biogas plant.
Hanji, बताइए.
But use the warm water, we need extra energy.
Very right.
Yes. So what is option to use overcome this problem?
Okay.
Instead of using warm water.
Fine. Actually, you are very right. It will really add to the energy when we use warm water to for the generation of the biogas in a better way during winters. So there, if you just go back, you'll see there are a lot of other methods also, alternate methods also, which can be.
Hello. Hello.
Anjim,
your voice is cracking, ma'am.
My voice. Acha, you are not. Kya voice is?
Your voice is cracking, ma'am.
Okay, fine. I'll take care. What is can be done is you can add slurry instead of using the warm water, or what you can do is you can add this jaggery or lassi जिसको बोलते हैं क्या buttermilk, right? They can add they can add to the generation of biogas production during winters. They are the low cost methods. rather than using the warm water. Okay.
Yes, ma'am. Thank you, ma'am.
Next sentence, please. No questions. Then the participants from our institute side. Any question? Yes.
पर लीटर कॉस्ट है कितना
किस में?
लीटर्स में हम गैस का
Gas.
Regarding the subsidy, madam, is it 30% presently?
No, it changes over the year. What happens is the policy of Government of India, that I don't know the exact cost, because it is not evaluated as such. Generally, it is not commercially feasible, so it has not been evaluated on that pattern. Only the investment cost has been evaluated, right? Like for 2 cubic meter plant, generally we invest around say 12,000 rupees in the KVIC type of biogas plant. So that is being generally the parameter through which it is evaluated. Yes, and subsidy, it you see, Government of India, they vary the subsidy every year depending upon the utilization or the disseminated usage of that particular technology. Right, every year the policy changes.
It was in solar system.
Yeah,
It
yeah.
was more than it decreased.
And decrease. You see, in the solar water heater, पहले 50% subsidy थी, and now there is no subsidy in Chandigarh. And there are two types of subsidy. One is central government and one is state government. You see, central government it is uniform for all states. That minimum every state government will provide to the beneficiary. But over and above, depending upon the state policy, this subsidy can be added. Now, I think there should be some subsidy still for KVS, especially for the this schedule caste and hilly and tribal people. Like, they generally provide the subsidy for the this thing. SC, ST, they have certain subsidy pattern. For other beneficiaries also the pattern is different, and also it depends upon every year. Every year it changes. So you have to go to the website.
Excuse me, ma'am. DID University has a doubt.
हाँ जी, बताइए.
Yes, ma'am. What is the future scope in research work in electrical perspective in a biomass system?
Okay. Future scope. When we talk, the
In
main,
research work.
yeah, like in the gasifier, we have the power generation, right? Through usage of biomass, we generate energy, but still the efficiency is low. Another thing is the production of the tar and other contents. That is another problem which is being looked into by various researchers. That this how to handle the waste which comes out by burning the fuel in the biomass gasifiers. That is another research area.
Okay. Thank you. Thank you.
So, if there are no question, then I'd like to thank all the participants for the patient hearing during this session, and we will have another session after an hour at 2 o'clock. 2:15. We'll have another session, right? So kindly assemble in time. Thank you so much.
जी हैं साहब। ओ भाई लंच ब्रेक चल रहा है अभी तो।
लंच करते हैं यार लोग सच में, लंबे लंबे लंच।
चलो इसका अभी मैं गया नहीं ना नीचे।
इसमें तुम कैसे दिखाई दे रहे हो अकेले?
कहाँ दिख रहा हूँ मैं?
तुम अकेले आ रहे हो।
यार ये क्या है?
कैमरा
नहीं फ्रंट वाला कैमरा ऑन है क्या इसमें? हाँ ये वेबकैम कनेक्ट नहीं है शायद।
Hello, ma'am. Good afternoon. शुरू कर सकते हैं?
Yes, yes.
A very good afternoon to one and all. So our expert will be coming shortly in 5 minutes. She got stuck in the traffic jam. So now I got the call from her. She'll be there around 5 minutes. So we'll just start in 5 minutes. So today's our expert is Dr. Anu Singla. She is an associate professor at Chitkara University. And she is an energy auditor also. So mainly this lecture was given to her because the energy audit, a general person talking about energy audit and an auditor talking about is different. So that's why we have just called her, and she has also conducted audits, and I think she has very good material regarding these energy audits. And I think all the centers also, please note this, if you people are interested in writing this exam of energy auditor, or if your students are interested, you can even ask her about what is the procedure and how to become an energy auditor. Like apart from your work, side by side you can also do this, so that also you can just note it down, how to become an energy auditor, like so what are the steps and all those things. And we have some small change in the timetable also. I think I have sent you people the Homer lecture, which was planned on Thursday. It was from 9 o'clock, but the expert, he is coming from out of station, so he wanted to keep it in the second, like 11 to 11:45, from 11:45 to 1. So the Homer lecture will be from 11:45 to 1, and in the afternoon again it will be continued from 2:15 to 4. So Homer will be adjusted like that. And the afternoon, in the Thursday afternoon, the power quality issues, that will be kept in the morning first lecture, like 10 to 11:45. So that one small change we have done there, and otherwise I think the other timetable is okay. So if you have all the centers, I want to make one more announcement. I think you would have done the registration, and I think you have all the participants list. So all the coordinators, please send me the list of participants, especially in the format which I have sent you, because always we get the participants list in a word form or different, but we have to send it to one of the department where they make the certificates. So they want it in the Excel form. So for every coordinators, I have sent the format. If any of the center they didn't get it, please you can just inform me now so that I will resend it. Okay, I have sent you format, Excel format for participants list. So I want you people to fill the participant list and please send it to me within this week so that we can also process it. And the bills also, the like stationaries and consumables, the bills which you have which you have got, please keep that safe. And once the course is over, along with the attendance, I think you all are taking attendance morning and afternoon. So with the attendance sheet, with the list of participants, and with all the bills, you will be sending it back to me in the next week. So please, only 7 centers are there. So you can, all the centers, just those who, if the coordinator is not there, please inform the coordinator. And I just want the list of participants by Friday, so that I can start the process of certificate. Okay, so this is the announcement for the centers. And tomorrow morning we have Supreet ma'am. Like I have written SLS, but it is not me. You have an expert. I have sent it in the new timetable. So she is from UIT. She's associate professor at UIT under Punjab University. So she will be giving you on energy efficient technologies.
Hello, ma'am.
Yes, sir. Once again, I couldn't hear. Yes, sir.
Madam, we have received the schedule, but
Yeah.
we have not yet received the slide format.
Okay,
So
okay. Yeah,
please
yeah,
send
yeah.
us.
I remember. Vyas College, is it?
Yes, ma'am. Yes.
Yeah, yeah. For others, I've sent Vyas, like only that schedule I've sent. I'll be sending you today itself. Okay.
Fine,
Now,
ma'am. Fine.
once my expert is here, I'll be going back. So I'll be just sending you the other
Sure.
details. Yeah, you
Thank
should have the attendance sheet also, sir.
Yes,
Attendance
we are
sheet
having
morning
it.
and afternoon. Then have the
Yes, ma'am.
feedback form. So I want all the centers to fill the feedback form on the last day. So that also you will be sending it with the bills and all those things. Okay, so
Fine.
Vyas, I'll be just sending all the other colleges I've sent. I think their experts will have Vyas Institute and Technology. I'll be just sending you the details. That I'll do.
Thank you. Thank you.
जी सर आप कौन से कॉलेज से मुलाना से
And the participants here also.
ठीक है
And participants here also, like if you are interested, say we have a solar wind PV system in our lab. So after 4 o'clock, the demo is going on with fuel cell is also there. You can also join us. After 4, you can just come to the power electronics lab. Yeah. In the electrical engineering department, ground floor. Electrical engineering department, you come to the power electronics lab. There you can see hybrid wind PV fuel cell battery system. So it's a hybrid system. We have other systems also. You can just come to the lab and have a look at it. Okay.
मैम मुलाना के पास कोई फॉर्मेट्स नहीं
Okay, Mulana की भी मैं भेज देती हूँ because I think Mulana also like वो उनकी कोऑर्डिनेटर अभी चेंज हो गया. पहले अखिलेश अभी विकास सर है. ओके मैं उनको भेज देती हूँ. उनका भी मेल आईडी मेरे पास है. मुलाना एंड ये भेज देती हूँ. So our expert सुन रहे हैं ना those people? So our expert has come and I've already introduced you and I've so we'll just आपका पेन ड्राइव है और हाँ पानी चाहिए मैम. एक मिनट. ओके यहाँ है. Energy audit February 9. That is the thing, no? This I'll keep it like this itself, no? You want to? Should I put it in the document? Only this energy audit or other things also? Only this. You can come here. No, campus. I've introduced you. I told you an energy auditor also. So कुछ होगा उसका भी पूछेंगे.
So should we start?
Yes.
Very good afternoon to all, and I'm extremely sorry for being late. So today's the topic of discussion is about energy audit. So before we start with energy audit, I will cover a bit detail of what is the energy scenario in our country, why is there is a need of energy audit. Then I will be covering what is the methodology to conduct the energy audit and how to prepare the reports and all. Then I have taken a case of the electric motors. Then there is one small student activity which can be done at our institutional level. Now, if we see India's energy scenario, India is world's third largest producer of electricity in the year 2013, with 4.8% global share in electricity generation. India was ranked sixth in annual electricity consumption, accounting for about 3.5% of the world's total annual electricity consumption. And if we see that the annual electricity generation consumption, it has increased about 64% in the past decade, and its projected rate of increase is one of the highest in the world. India was the fourth largest consumer in the world of crude oil and natural gas. After the United States, India imports about 3/4 of crude oil, and country's oil bill accounts for 37% of the total value of all imports. Excuse me, the images are not coming up. Yeah. The photographs are not there.
मैम आपने लिंक दिया था ये कहीं से?
No, these are the images.
वैसे बता दीजिए, स्लाइड शो मत कीजिए तो
हाँ जी मैम, स्लाइड शो जहाँ पे इमेज है ना, यहाँ भी नहीं आ रही है।
यहाँ पर स्लाइड शो मत कीजिए, यहाँ पे ऐसे बता दीजिए।
यहाँ भी नहीं आ रही है इमेज।
Should we restart our system?
सिस्टम की प्रॉब्लम नहीं है मैम, आपने ना आपका मैक तो नहीं है मैम सिस्टम?
No.
मैक होता तो प्रॉब्लम हो जाती है।
Open the recent documents. Click yes.
इधर बाजू वाले में नीचे ग्राउंड फ्लोर
नोट करना है।
नीचे सबसे नीचे
ये आ रही है बस। मैम आपके लैपटॉप वहाँ से कनेक्ट कर देते हैं।
Kindly wait for 2 minutes. There is some problem regarding the images in the PPTs.
आप बाद में ऑन कर लीजिए। ऑडियो जाएगी वहाँ से, इसे ऐसे बना दीजिए, यहाँ से ओके इतना करें।
We continue with the discussion. So it was like India was the fourth largest consumer in the world of crude oil and imports about 3/4 of crude oil. And if we see 68% of our population lives in rural India and 80,000 villages, they are still unelectrified. At one scene in the urban areas, we talk about the traffic jams and all, and there are certain areas where the people, they have to walk miles to fetch one bucket of water. At one time, we talk about the models of the cars, bikes and all, and there is another scenario of the country where the people, they don't have any mode of the any transport mode. The government is talking about the rural telecom, rural banking and all, but all these things, they will not work well without a stable power. And if we talk about the electricity energy consumption in the field of agriculture, India is highest with 18%, followed by Iran and Pakistan. If we talk about the traditional fuels, no doubt we are using LPG gases at our homes and all, but there are nearly 800 million Indians which use traditional fuels, and these traditional fuels, when they are burnt in the chulhas and all, they release large amounts of pollutants, and nearly 3 to 4 lakh Indians die of indoor air pollution and carbon monoxide poisoning every year because of biomass burning and use of chullas. And if we see that there are cities where there are no power cuts, but when the power cut occurs, even inverter is not working. This is the normal scenario in a normal family of the country. So it means energy matters for all of us. And if we see what will be the forecast of the energy in the years to come and all, global demand for all energy sources is forecast to grow by 57% over the next 25 years. 56% of the world's energy use will be in Asia by 2030, and India's demand for all types of energy is expected to increase by 41% within 25 years. If we have to meet these energy demands, we have to add the power generation capacity. So nearly 300 power plants, each plant of 1000 megawatt capacity is required to meet demand by 2030. So it means there is a lot of generation. We are producing electricity and all. Still there is a deficiency of the power. At one time there are no power cuts, and there are certain areas of the country which are still unelectrified. So it means now there is need not only to talk about the generation, but we have to work on the demand side also. So we have to manage our demands. And so that's the only solution, that reduce demand through energy efficiency and conservation. So there is a dire need of energy management in current scenario. And if we talk about the pyramid of the energy management, is energy conservation, which is followed by energy efficiency, that is adoption of energy efficient technologies, then moving from fossil fuels to the renewable sources of energy. Because when we talk about the energy management and all, at global level there is a concern of global warming, climate change and all. For national, we want to improve our energy security by reducing the dependence on the imports. And when we talk about the common person and all, we want, any industry, it wants to reduce their energy bills and all. So if we see what is the potential for energy conservation in different sectors of the country, so this is some of the data that if we talk about the major energy intensive sectors, then we can see from this data there is ample scope of energy conservation. And if we talk about India, we have the high level of energy wastage, and energy intensity per unit of GDP is 3.7 times of Japan and 1.5 times of the USA. I have just taken an example of three sectors, aluminium, steel and cement, and we can see that how much energy we are consuming per ton of the production vis-a-vis the world scenario. And when we talk about the Indian industry, there is a large benefit of specific energy consumption across the industry. We have latest modern plants with very low specific energy consumption, and then there are some industries which are using obsolete technologies. So that bandwidth of specific energy consumption is very large in our country, from modern plants to the outdated plants. So what is the role of energy audit in this scenario? Energy audit will help in identifying the areas where waste is occurring and where there is a scope of improvement. So primary objective of energy audit is to determine ways to reduce energy consumption, hence reducing the energy bills. And when we talk about energy, we are talking about electrical and thermal energy, so electricity as well as the fuels which are being used. And if we see what is the electricity consumption across the different sectors, then we see that industry consumes 44% of the energy consumption, and which is followed by the domestic sector, which is 22%, and then followed by the agriculture sector and the other sectors. So today I shall be talking about what are the energy, how to carry out the energy audit in an industry, and it will be followed by one small example which is applicable to any buildings. So that is mainly covering the domestic sector and applicable to industry also. So when we say that our industries, they have to become globally competitive, then their products, they have to be energy efficient, and the production process, it should consume the least amount of the energy. So energy audits and conservation studies, they must be conducted in all types of industries at the regular intervals, although it is mandatory for the energy intensive industries, but all the industries, they should follow this practice. And when we see that what are the major components which are consuming energy in the industry, in general, it's the electrical system, which comprises in lighting, electrical motors, then we have HVAC systems, compressed air systems, fans, blowers, boilers, refrigeration and drying unit. These are the major components which consume energy in the any general industry. And energy management is basically defined as the judicious and effective use of the energy to maximize profits. And if we talk about what are the 4 pillars for the successful energy management program, first is technical ability, then there should be a very effective monitoring system, then there should be strategic planning to implement the energy management programs, and above all, the things flow from the top management. There should be a support from the top management to carry the energy management programs in the industry. And energy audit is basically a key to a systematic approach for decision making in the area of energy management. So when we say that we have to manage something or we have to carry an energy management program, it is based on some of the data analysis and all, some of the recommendations. So all data analysis, everything is done through the energy audit. So if we see that how the Energy Conservation Act 2001 defines energy audit, so according to it, energy audit means the verification, monitoring and analysis of use of energy, including submission of technical report which contains recommendations for improving energy efficiency along with the cost benefit analysis, and then an action plan to reduce energy consumption. So this is the precise definition of the energy audit as per the Energy Conservation Act, which includes everything with the follow-up action. So for any industry, there are the 3 top operating costs. One is of energy, another is labor, and then there is a materials. And if we see amongst three major energy cost components, energy has the highest potential for the cost reduction, especially for the energy intensive industries. So what energy audit does, it basically balances the total energy input with its use. It identifies all the energy streams in a facility, and it helps to understand about the ways energy is used in the industry, and we can identify the areas where the energy is wastage of energy is occurring and where we can improve the energy conservation in the process. Now there can be different types of energy audit. The type of energy audit performed, it depends on what is the type of the industry, what is the depth to which final audit is needed, and what is the potential and magnitude of cost reduction desired by the industry. So accordingly, we can define energy classify energy into 3 types. One is the preliminary energy audit, the second one is targeted energy audit, and third is the detailed energy audit. When we talk about the preliminary energy audit, it's a simple walkthrough audit that you just go to the industry, meet some people and just go through the plant to get familiarized with yourself. Then there is a targeted energy audit which provides the data and detailed analysis on the specific target projects. Like say one industry wants to carry out the audit for say lighting system, or they want to work, there is a leakage of the steam and all, they want to get the energy audit of the steam system, then the targeted energy audit is done for some parts of the industry. So in this audit, we do the analysis of the energy flow and what is the cost associated with that specific area that part is being done. And when we talk about the detailed energy audit, basically it's a comprehensive audit and results in a detailed energy project implementation plan for a facility. So it includes detailed energy cost calculations and project implementation costs, and this audit is carried out in 3 phases. So first is pre-audit phase, then it's a audit phase, then it is a post-audit phase. To carry out the detailed audit, there is a 10-step methodology which is the standard procedure to carry out the energy audit in any of the industry. So there is a phase 1 pre-audit phase, that is step 1. So it is like a walkthrough audit which we talked about the preliminary energy audit. It's just the person goes to the industry, meet with people, and it's an informal kind of interaction. And the purpose is that we organize the energy audit team and then we need to find out what is the instruments required. Then some macro data collection is made, and then there should be familiarization with the process of the industry. Then there is an introductory meeting with all divisional heads and persons concerned with energy management. It is done just to build the rapport and with the team, because when the audit is being conducted, is not only external team, there are some members from the industry which form a part of the team, which provide all the inputs and all. Then there is a audit phase. After getting all this data, then we get the primary data gathering, that is process flow diagram and energy utility diagrams. So we take the data from the invoices, what had been the electricity bill, what had been the fuel consumption of the process, what is the production, what is the fuel consumption, then what are the then accordingly we take the single line diagrams, then what is the compressed air and steam distribution, and accordingly we prepare the flow charts. Then we design operating data and schedule of operation, and the inputs they are taken from the electricity bill, and we study what is the energy consumption pattern. Then the survey is conducted, that is the step 4. After getting all the data from the industry and all, then the survey is conducted and the data is being monitored. So we may have to take some of the measurements and all, which are elaborated later on also. That is like what is the motor survey, what is the lighting, what kind of lighting systems are being used. Then there may be some of the existing instruments, and we work out if some additional instruments they have to be deployed to take the readings and all. Then there is a conduct of the detailed trials, that is step 5. That is the monitoring of the power factor, energy of the plant, then what is the load variation trend in pumps, fans, compressors, then boiler efficiency trials, furnace efficiency trials. And accordingly, then we step 6 is the analysis of the energy use. We make the energy and material balance, and we work out what is the energy loss in the whole process. We make the flow chart, and we take what is the energy input and what is the production, and throughout the process what are the energy inputs and where the loss is occurring. So in 7th step, we identify and develop the energy conservation opportunities. We work out, okay, this is the complete process, and this is the load pattern and all, and this is the measurement data says, and accordingly work out what are the energy conservation opportunities in different processes, and those things they are being discussed with the internal team also. Then after giving the recommendations and working out like what kind of energy efficiency opportunities are there, then cost benefit analysis is done. We work out what is the technical feasibility of the recommendation and what is the economical viability of the project, and accordingly we set the priorities for the recommendations. The most promising projects they are selected immediately, and there are certain recommendations which involve high cost and they need the approvals from the management and all. So those things they are being put at the later stage. So these things, all these points they are discussed in the subsequent slides also. Then all the things are documented, and then draft report is being ready and the presentation is made to the management. Then after getting the feedback from all internal and amongst the team members, the final report is made. Then the third is the post-audit phase, where the follow-up action is also taken. So after recommendations are given and all, we prepare a action plan for the recommendations. Then we monitor that if those recommendations are incorporated in the plant, then what had been the energy inputs and all, how the process has improved. That is a periodic review of all the recommendations made and the follow-up action. So I discussed all those points into a bit detail. So we had 3 phases. Phase 1, that was the pre-audit phase, in which the team visits the campus. It basically walk-through audit, and the main aim is to finalize energy audit team to identify the main energy consuming areas and plants to be surveyed during the audit, and to identify the instrumentation required for carrying out the energy audit. And then we see that the instruments already installed in the industry, are they sufficient for our purpose, or we have to install some of the instruments to take the readings. Then we analyze the major energy consumption data with the relevant people, then obtain all the drawings, and again create the awareness through meetings and program. in the employees of the industry. And during the phase 2, that is the detailed energy audit activities, where we conduct the survey and take all the readings and all. So the information to be collected during the detailed audit includes energy consumption by type of energy, by department, by major items of process of equipment. When we say type of energy, it means there may be different kinds of fuels are being used, and there is a electricity consumption. So we put, okay, electricity is consumed by these processes, say this fuel is consumed by these processes, then which department is there, so accordingly we work out. Then we make the material balance data. So material balance data means what is the raw material used, then what are the final products, whether recycled material is used, if there is any byproduct, or if the byproduct has to be reused in the industry, or there is some waste heat recovery and all. Then we study what is the energy cost and tariff data. Then what is the source of energy supply, whether there is some captive power plant, there is self-generation in the plant, like some of the industries, they install their own power plants and all, or if the electricity is taken only from the grid. So these certain parameters, they are being stated in detail during the phase 2, that is the main activity, that is the audit phase. Then we take the process and material flow diagrams, the whole industries from the simple, starting from the raw material to the final product. The complete flow diagram is made, like how the energy is flowing, what are the steps involved, what are the different processes of the industry. In during the whole complete process, like there are different stages for the final product to be made. So during each stage, what kind of energy is being used, what process is being followed, and what energy saving opportunity is available where any leakage or wastage of energy is occurring. Then what is the potential for the fuel substitution if the process has to be modified, or if there is a use of the cogeneration system. If there are already some ongoing energy management program, then those programs, they are being reviewed. So when the audit team enters the industry and takes all the data, so these are some of the points, some basic data which needs to be collected from the industry, like what is the quantity and type of the raw material used in the industry. Then what is the technology, what is the process used, and what are the details of the equipment. So sometimes the process is such that there are certain new technologies involved which make the process shorter and make the process more energy efficient. Then what is the capacity utilization, what are the efficiencies, and what is the production yield of the plant. Then what is the percentage rejection, what is the reprocessing, what is the quantity and type of waste occurring in the industry. Then what is the consumption of the fuel, steam, electricity, compressed air, cooling water, chilled water. So these are some of the tips, some of the data which is to be taken for the energy audit of the industry. And there are certain tips which if we follow them, we can avoid our time in collecting the data and all. So one thing is that measurement system should be easy to use and provide the information to the accuracy that is needed, not the accuracy that is technically possible. So take the data in the form which is required for your calculation purpose. Sometimes, like because we have to find out the energy saving opportunity in that process. So accuracy up to second decimal or third decimal may not be required. We just want to know, okay, what are the inputs and how the process is taking place. Then the quality of the data should be such that the correct conclusions can be drawn. Sometimes what happens that we take the data, but when we sit to analyze the data, then we are not able to conclude anything from the data. So then the whole exercise gets wasted, and then again we have to get to the plant to work out the additional data. Then we must know that if I have to work on this process, then what should be the frequency of the data collection. If the data is to be collected on the hourly basis, or 3 times a day data is required, or some weekly data is required. So it depends on what kind of process is there. Then what are the data has to be collected when the machine is starting and when the machine is shut down, because during the starting it may draw a large amount of the current, and then what is the power flow when the machine gets shut down. And sometimes it's not possible to take the measurements. In those cases, we can take the design values or the readings on, or the specifications from the nameplates to take the read. Now, once the data is being taken and all, just draw the complete flow diagram and list the process steps, which I have discussed earlier also, that there is a complete process flow diagram that from raw material to the final production stage, what are the various steps involved, and all the steps they are being listed. Then the complete energy flow diagram is drawn, and from there we find out where the energy waste is occurring. Then we need to work out what are the energy conservation opportunities. Like when we sit for the first time that okay, we have taken all the readings and all, then broadly there are 4 categories where we can work out that what are the energy saving opportunities. First, say we are talking about the electricity and the thermal energy. So when there is any fuels they are used in the process and all, then fuel substitution is one of the opportunities to save the energy. So just find out if the existing fuel can be replaced by appropriate energy efficient fuel. Then when we talk about the generation process, then find out if we can find out any energy efficient opportunities in the energy conversion equipment, such as captive power generation, cogeneration, steam generation in boilers. Then optimal, if DG sets are normally used in all the industries, either for the peak load or whenever there is a breakdown of the grid. So what is the optimal loading and high efficiency of the DG sets? Then what is, if the boilers are being used, then what is the minimum excess air combustion? What is the optimizing existing efficiencies and all. Then we talk about the energy distribution systems. We can work out where are the energy efficient opportunities exist, like in transformers, cables. See, if there are loose joints of the cables, the terminations are not done properly, then lot of energy gets wasted. And sometimes the cables are overloaded. If they are not sized properly, then again power loss is occurring. Then what is the switchgear? If the power factor needs to be improved, then compressed air systems, cooling water. So the complete energy distribution system. Then what is the process of in the industry? Now this is the area where there can be like some of the plants when they are updated. Updated means they have changed the technology. The process to develop the product has been changed. So this is the main area where the energy saving can take place. And when we work out what are the power costs in the industry, when we see the electricity bill and all, we have to see that electricity bill is based on which components. Like utility charges the bill on different components, like maximum demand charges are there, then energy charges are there, then time of day charges, whether peak demand or non-peak period. Then power factor charges are there. Then there are some incentives and penalties which are offered by different electricity boards. Then high tension tariff, low tariff rate charge, slab rate cost and its variation. Then type of the tariff clause and tariff rate for developed and underdeveloped areas. So the auditor should have the understanding of what are the different components of the tariff, and on the basis the electricity bill of that industry is coming. So sometimes like say shifting the process from peak hour to non-peak hour can result into the energy saving. Sometimes there are certain because your demand has exceeded the level, so there are certain penalties which are being put by the industries. So that components they can be worked out, and we can see to it that how the energy can be saved, like how the electricity bill can be improved by just making some changes in the system. So power cost and the fuel cost, both the understanding of the energy cost is must. And when we say fuel cost, there are wide variety of fuels which are available for thermal energy supply. Some of the commonly used fuels in the industry are fuel oil, then there is low sulfur heavy stock, then there is a LPG gas, coal, lignite, wood, etc. Now, availability of the fuel, the cost of the fuel, and the quality of the fuel, they are very, very important. So when we see that what is the cost of the fuel, we just don't see what is the cost of the fuel, but what are the transport charges involved, what type of transport is involved in the fuel. Then what is the quality of the fuel? If there is any contamination, whether there is any moisture.
Commercial or this is Ranjay Singh from DIT University.
Yes, sir.
Ma'am, could you please switch back to the previous slide?
Yes, sir.
Ma'am, what I'd like to know is that our residential complex also charged for the reactive power they are consuming, or for having a poor power factor as a residential load.
Sir, please will you repeat your question? Normally, reactive power factor penalties are given in the
industries are concerned. As far as the industries are concerned, they are charged for their kVAR rating and kilowatt rating for both of them. For the residential complexes, do we? I mean, are we charged, or is there any prospect or of the residential load being charged for their kVAR rating as well?
No, sir. Actually, they are not charged for the meter. They are charging for the kilowatt hour. And what is the energy consumed? That takes care of the power factor also. So, reactive component is not separately charged for the residential. And coming to the industry, like Punjab, even the industry is charging on the base of kVA now, not on the kilowatt hour now. So this is a recent development in the electricity boards that they have started charging the industries now on the base of the kVA. So even that is one amendment in the tariffs for the industries also. But
are there any prospects for residential load also being charged in form of kVA rather than kilowatt hour?
Sir, may the times to come, it may be getting implemented to the residential consumer, but it will come after a long time, because first the industry they targets the bulk consumers, then commercial consumers, then it comes to residential.
Thank you, ma'am.
This was about the understanding of the energy cost, fuel cost, as well as the power cost. And when we collected the data from the electricity bills and other fuels, now we check the invoices of the industry, and we can work out what has been the total cost of the energy bill of the industry. Then all the fuels purchased by the plants, they should be converted to common units such as kilocalories. Then we work out like what is the major component, which component of the fuel is a maximum, like energy bill is a maximum for which kind of the fuel. Then we find out the energy consumed for the period. That is the formula C plus M into production for the same period. Now C is the constant cost, so whether there is any production or not, that cost will definitely occur because of some lighting, general ancillary services, heating, cooling and all. M is the energy consumption directly related to production, so that is production for same period. So we calculate energy consumed for the period, and then we find out the standard energy consumption for any level of the production. So this is how we work out that for producing 1 unit of the product, what is the energy input there. So what is energy consumed per unit product, like a product, whether it's in the form of number or in the terms of tons or all. Then when we talk about the fuel and energy substitution, the fuel substitution is basically substituting existing fossil fuel with more efficient and less cost, less polluting fuels such as natural gas, biogas and some other locally available agro residues. Now examples of fuel substitution are like natural gas is increasingly the fuel of choice as a fuel, then replacement of coal by coconut shells, rice husk, then replacement of light diesel oil by low sulfur heavy stock. So it means energy dependency can be reduced by 2 methods. One is energy conservation, another is the fuel substitution. So when we talk about the substitution, it is basically either fuel substitution or energy substitution. So example of energy substitution is like we replace the electric heaters by the steam heaters, and if there is a steam based hot water, that can be replaced by the solar geysers. So this is where like we can save the energy. And when we say what are the energy efficiency measures, then there are some active or efficient in-house management of energy efficiency through maintenance and housekeeping measures. and it may involve or it may not involve any of the costs. Say sometimes there is a place some leakage is occurring, you plug the leakage, there may not be any cost involved, but energy is being saved. Some motor is idly running, you change the process, there may be some cost involved or there may not be cost involved. So these are some of the in-house management of the energy efficiency. Then there may be a requirement of the replacement or retrofit of the selected equipment, which may require medium-sized investments and can be taken up. Then the final type is that there is a modification of entire manufacturing process which require the large scale investments. For that decision has to be taken by the management. Is basically high investment but high returns, and normally these kinds of energy conservation measures take long time to get implemented. So first thing, it takes a lot of time to get them approved, then the implementation stage comes, but yes, there are high returns on there. And sometimes what happens that although options are available, but the company has not enough money to go for the change of the technology of the plant. So once we work out what are the energy conservation measures in the plant, we study the different kinds of processes. So there may be different kinds of equipments involved, and we may work out what are the energy conservation opportunities. We provide our recommendations. Now the recommendations, they have to be technically checked, and we have to work out whether they are economical or not. So technical feasibility should address whether the technology available, whether there is enough space to incorporate that technology. If manpower is available, say if the industry, they don't have the trained manpower, and we talk about the new technology, it means enough time will be required to train the manpower, and sometimes the people, they are not, see, there are the old industry, there are very old technicians working there, so it may not be sometimes in a position for to them train to the new technologies. Then what is the impact of the energy efficiency measured on the safety, quality, production or process? Then what are the maintenance requirements and spares availability? There, what happens that like in the normal cases is also there, that new technology is available but the spares are rarely available or they are very expensive, and some equipments, they are very sensitive to environmental conditions and their maintenance requirements are very stringent. So when we recommend any technology, or we just offer, okay, this is the energy saving conservation, we have to thoroughly see whether it's technically possible or not within the constraints of the industry. And when we talk about the economical analysis, we can work out the economical feasibility of that recommendation by different methods. Simple method is the payback method. Basically, we want to work out that how after how many years the investment makes money. Then there is a return on investment. Basically, it's a measure that allow comparison with other investment options. Then the third most important is the net present value method. So basically, it is a measure that allows financial planning of the project and provides the company with all the information needed to incorporate energy efficiency projects into the corporate financial system. A very simple and very basic example is that like say we have to say that solar, like we want to install the solar power plant in the industry, because there is our solar geysers are required and all. Now see, if we have to invest the solar power plant, although it's not a very basic example, now some investment has to be made by the company. So they have to see whether they work out the complete details. If we install the solar power plant, how much energy is made, how the DG cost can be replaced by the solar power plant, or if they are not using the DG sets, then it may happen that the electricity cost may be less than the cost involved in setting up the power plant. But there are certain processes in the industry, if we change them, there will be a huge investment required, so that net present value has to be find out for that new implemented project. Now when we say that we have worked out the economic feasibility, this is basically a format by which we can work out that say we work out what is the energy efficiency measure. Then there are three columns. What is the investment required to implement that energy efficient measure? Then what are the annual operating costs? Then what are the annual savings? When we talk about the investment, means what is the cost of the equipment? What will be the civil work required? What kind of instrumentation required? Or if the existing instrumentation will be enough, or some new instruments will be required, or if there are certain auxiliaries required to implement that new technology. Then what is the capital cost? What is the maintenance? What new manpower or existing manpower required? What will be the energy consumed by the new process, and what will be the depreciation rate? Then we work out what are the annual savings. Annual savings can be in the form of thermal energy, in the form of electrical energy, in the form of raw materials or waste disposal. At some of the processes, waste disposal itself is a energy intensive activity. Accordingly, we work out what are the net savings per year. Then we find out the payback period in months. Now, in the complete process, say there are 10 recommendations or there are 15 recommendations. For every kind of recommendation, this kind of a format will be prepared. The auditor can use any other method to do it. This is one of the formal way of putting the things into the document form. Then whatever the energy saving measures they are suggested by the auditor, we put them into 3 categories, like low cost, medium cost, high cost. So there may be some of the projects in most of the industries you find that the cost involved is very low, but the returns are very high. Then there are medium cost, medium return projects. Then there are the certain projects where we some retrofitting or some technology has to be changed that in calls for high cost, but the returns are also high. So normally we set the priority for the projects. The low cost, high return projects, they receive the maximum priority. But the projects which are related to high cost, although returns are high, but they need a careful scrutiny before the funds can be committed. So it means in the first sheet, we gave all the energy efficient measures, we did the payback period. From that data, we set the priorities, we work out what are the low cost, medium cost and high cost. We categorize accordingly. Now, then we set a priority, project priority guideline. Like say there are 10 recommendations, then we categorize them in low cost, medium cost and high cost. Then we set the priorities like A, B, C, D. These are some of the priorities. Like we set the priority A. We work out the 3 columns. What is the economical feasibility, technical feasibility, and what is the risk involved. Now, A means say is a very good project. Economically, it is very well defined, very attractive. Existing technology is adequate, no risk. So we put it highly feasible project, and these projects they normally go get a signal of go ahead immediately. Then the category B. B means the project is well defined but marginally acceptable. The existing technology may be updated, but there is lack of confirmation. There may be a minor operating risk, but may be feasible. Then there is a C category, project held. Means we have poorly defined the project, marginally unacceptable, existing technology is not adequate. Then it means risk or feasibility is doubtful. Whether we want to go ahead or not is doubtful case, and it needs further scrutiny of the project. Then we put a grade D. That project is not attractive and is not feasible. So accordingly, we set the priorities. Some of the recommendations they are straightway rejected, and some of the recommendations they are immediately accepted. Now, once we did the audit kind of a thing, then we have to prepare a report of the energy audit. So this is the standard procedure of preparing the report. At the beginning, we write the acknowledgement. Then there is an executive summary, which give the energy audit options at a glance. Because most of the time, management they don't have enough time to go through the project details, so they just read the executive summary. Then you provide the introduction about the plant. Then what is the production process description. Then energy and utility system description. Then a list of utilities and brief description of each utility. Then what is the detailed process flow diagram, what is the energy and material balance. Then energy efficiency in utility and process systems. Then what are the energy conservation options and recommendations? So like all the data which we have discussed, like what kind of formats need to be prepared, they become a part of the report. We just give the list of options in the terms of no cost, low cost, medium cost, high investment cost, then annual energy and cost savings, payback period, all the financial aspects are being carried out. Then we provide the implementation plan for the energy saving measures. That if we set the priority, now these projects, they have to be implemented in some sequence or phased manner. So that complete activity chart is provided. Then some annexures, some data collection details, anything is required, they are put as the annexure. Now this is one of the standard format or some of the guideline to prepare an energy audit report. And when we talk about the summary of energy saving recommendations, when we write down energy saving recommendation as a first, there will be a detailed sheet for like energy saving measure separately. But when we have prepared the sheets for say 10 measures, then from those sheets we calculate the key points, like what is the recommendation, what is the annual energy saving, what is the annual cost saving, what is the capital investment, and what is the simple payback period. So this is the summary of all the energy saving recommendations. In actual, this is the summary which is prepared from the detailed analysis of the each energy saving measure, where we do all the calculations. We work out, okay, this light will operate for so many hours. So all those data calculations are there. So all detailed data calculations are there, from where at the end we put some recommendation. Then all the recommendations, they are compiled together from all the data sheets. Then types and priority of energy saving measures, as I discussed, that we put them grade A, B, C, D and all, or we put in the terms of low cost, medium cost and high cost. So when we have made the recommendations, they can be put into these three categories. Like priority, we set the priority for the energy recommendation measures. Like first we said no investment, because it's just the operational improvement, and a bit of housekeeping is enough to improve the energy process of the industry. Then there can be a low investment, short to medium term. Say there are some controls are being changed, some equipment is being modified, or some process change is there. Then the third, that is high investment, where we have made use of energy efficient devices. There is some product modification or there is some technology change. So from all the recommendation measures, we have compiled them. Then we put made a summary of them. Then we set a priority to all the energy recommendations. Now the third is the post-audit phase. So whatever energy action plan has been prepared on the completion of energy audit, it lists all the energy conservation measures which should be implemented and suggest an overall implementation schedule. We provide the complete action plan. Now once the audit is covered, that doesn't mean that the auditor now is not bothered or concerned with the industry. So we have to monitor them and we have to get the feedback from the industry, like what is the electricity power consumption. We evaluate what recommendation we made, whether they are implemented or they are not implemented. If they are implemented, then what are the energy savings actually taking place. So that complete follow-up action is there, which may be after 6 months, after 4 months, or after 1 year, and that period can be specified at the time of the getting the order for the energy audit. So these are the three phases of the energy audit, any detailed energy audit. Phase 1, phase 2 and phase 3, that is a post-audit phase. So this is a brief view of carrying out the energy audit in the industry. These are the different steps involved in carrying out the energy audit. Now when we have to carry out the energy audit, we may need some of the instruments. First thing, we have an apprehension that if we have to carry out energy audit, we need a very sophisticated energy audit instruments. Sometimes only 1 or 2 basic instruments are required, and they are more than enough for the general industry. Although for a large industry, you may need some more instruments and all. and there are many parameters which are applicable for one industry or may not be applicable for one industry. Boilers, all the industries may not have. There are different kinds of industries, they have different kinds of processes. So there are certain things which are not applicable to one industry. One industry may have a lots many furnaces, the other industry they may not have any furnaces. So these requirements they change. So when we talk about the energy audit and all, what are the basic parameters which we need to measure? When we talk about the electricity and all, the basic parameters are voltage, current, power factor, then active power, apparent power, reactive power, frequency and harmonics. And then other than electrical are what is the temperature, heat flow, radiation, humidity, moisture, then pH value, then flue gas analysis if there is any combustion boiler is there and all, what is relative humidity. So these details are required. So I have just listed few of the instruments, but I have given a link. I have given a link where from you can get all the details of all energy audit instruments. It's a simple power analyzer. Again, it comes in the range of starting from 20,000-30,000 to in the lakhs. But it all requires what current ratings, what details you need. You need a data logger, you don't need a data logger. So these are the instruments which can be put online system. We don't need to stop the motor and all. They directly online take the readings. Then there are thermometers, because temperature is one of the factors which is mainly need to be measured in all types of industries. Now we have a contact thermometer, then we have a infrared thermometers. So infrared thermometers, they are basically used because they are non-contact type. From the distance you can take the temperature reading. So they are used for measuring hotspots in furnaces and the surface temperatures, etc. Then we have the lux meters, because when we have to work out the lighting design of the industry, we have to take the readings of the lux levels. So this is a simple instrument which is used to measure the lux levels. Then there is a combustion analyzer. Then there is a fuel efficiency monitor. This fuel efficiency monitor measures the oxygen and temperature of the flue gas. Calorific values of common fuels are fed into the microprocessor which calculates the combustion efficiency. Then speed is again plays a very important role. We need to check the speed because it may change with the frequency or with the loading. The instrument can be non-contact or it can be just measured from the distance. So tachometer is a contact type. Stroboscope is a non-contact instrument which is used to measure the speed. And there is one link from where you can find out the detail of more energy audit instruments. There are a number of instruments available. I had just put some of the basic instruments which are used. I think this presentation may be available with you. Now, this was all about the energy audit and all. So I have just taken one case study of the electric motors, because when we say that we have to find out the energy efficiency measures in the complete process of the industries. So I can't discuss all kinds of process, whether it's a compressor system, is boilers, or is a HVAC system, or is a like a pumps and all. So I've taken the motors because which is used in many of the processes and all. So I have just taken the thing that when you go to the industry, how to take the data from the electric motors and how can you find out that what are the energy efficiency opportunities and how can you conserve energy in the process. So I've just taken a brief discussion on the electric motors. So I will just go through fast because I have not covered the fundamentals, assuming that all electrical motor fundamentals are clear to everyone because all of us are from engineering background. So when we talk about the electric motors and all, these are some of the basic characteristics which needs to be understood. In fact, in addition to this, one must know what is the torque speed characteristic of the motor. And when we say electric motors, most of the industry motors, they are comprises of three-phase induction motors. And we call three-phase induction motor as a workhorse of the industry. So all the discussion on electric motor is pertaining to a three-phase induction motor. So one needs to know what is the torque speed characteristics of the motor. Then how the power factor and efficiency of the motor varies with the load. Now we see that as the load drops, the efficiency also drops, even the power factor drops. So motor operates a very low power factor at the lesser loads. As the motor gets loaded, the power factor gets improved. Now, these are some of the parameters which affect the efficiency of the motor, like what type of motor we are using, what is the speed of the motor, what is the capacity, what kind of enclosure we have used, and what are the operating temperatures, whether the motor is original or we have done the rewinding of the motor, then what are the loading conditions of the motor, then what is the age of the motor. More or less, age further depends on the maintenance part only. That age is, you can say, a function of the lubrication. Then it depends on if there are excessive high temperatures, then the age of the motor gets reduced. If there is any dusty environment, humid environment, or there are mechanical stresses due to load, all these things, they affect the age of the motor. Otherwise, if all those things are perfectly fine, the motor works for 20-30 years. It's not an issue. Now, these are, I had discussed what are the main factors which are affecting the performance of the motor. Now, I have listed some of the energy efficiency opportunities, and I have discussed each opportunity one by one. So, what first thing is reduce underloading, because, or you can say, avoid oversized motors, because if the motor is underloaded, then the efficiency and power factor goes down. Then the size the motor to the variable load, because sometimes the load is not constant. That part I discussed in that point only. Then power quality should be better, because if the power quality is not good, there are voltage or current unbalances, then that will affect the performance of the motor. Then rewinding, quality of rewinding affects the motor performance. Then power factor correction by capacitors. Then maintenance needs to be improved for the motor. Then there is a speed control of the induction motor. Then at the end we say that use energy efficient motors. Now I discuss all the points, like at a glance I can say, okay, when you go to the industry, these are certain areas where you can find out the energy efficient measures. So take take the data of the motors, then just analyze each point, and then you can give your recommendations. Now, why the motor is underloaded? There can be two reasons. One is when we selected the motor, we kept a large safety factor. So this safety factor is good when we are designing the buildings or earthing designings and all. But when we are motor is designed and we have kept the safety margin, what will happen? That we have chosen an oversized motor for a particular application. And when the motor is running, most of the time it is operating at a partial load, so efficiency is low. So, or sometimes what happens, that say we have used the motor for a particular process, but that equipment itself is underutilized, so it is not fully utilized, so motor load is less. Then sometimes happens that when we have to buy a new motor and all, what the designer has thought that if there may be fluctuations in the voltage, sometimes the voltage level goes down. Now he wants that the performance of the motor, the output of the motor remains constant, so he goes for the oversized motor, so that even if the voltage is low, the power output remains same. Now what happens that sometimes we need a high starting torque. So for high starting torque, we choose a motor of the higher size. Now that is why that we need to understand what are the speed torque characteristics of the motor. Now instead of choosing the high size motor, choose the motor which has a high starting torque, but the motor should be as per your load rating. So what are the consequences? The motor losses increases, the efficiency goes down, and the power factor goes down. And when we have to calculate the motor loading, this is how the motor loading is calculated. Actual operating load of the motor divided by the rating capacity of the motor. This is how do we work out that this is the percentage loading on the motor. Now, if the motor is underloaded, what kind of recommendation you can give? Replace with the smaller motor if motor operates at less than 50% of the load, but don't replace the motor if the motor is operating in the range of 60 to 70% cost, because then you won't be able to recover your cost. And then if the motor is consistently operating at load less than 40%, then delta motors, most of the time they are delta connected motors. You can wire the motor. There can be a wire reconfiguration, and the motor can be connected in the delta. This is one of the very cost-effective methods. But when we do this, the speed also goes down. Now, this recommendation should not be given to the production facility whose output is related to motor speed. So when we give the recommendations, we need to understand the working of the motor. We need to understand what is the working of the process. So it may not happen that we have gone for the energy efficient measure, but that has affected the quality of the production. Now coming to the second point, that is sizing to the variable load. Now what happens that motor selection is based on the highest anticipated load, which results in expensive and risk of the underloading. Now what happens, say there is a complete industrial process. Now during the complete process, the motor may be overloaded for just a moment, for just very small duration the motor is overloaded. Now instead of taking the motor of that higher size, take the motor of the base load, and the motors they are provided with the service factor, which is 15% or above can be taken. So service sector provides the overload facility for that motor. So it means like during the process, the momentary during that period the motor can be overloaded, but most of the during the process the motor will operate at the full load and the efficiency will be high. So that is sizing to the variable load. Now again, this recommendation should not be given if there is a risk of overheating. Say there are extreme load changes. So what will happen, that motor will not have enough time to cool down. So that's what happens, that if the motor is not cooling down enough, then if you have chosen the undersized motor, then it may result into the overheating, and that will affect the performance of the motor. Otherwise, if the process is such that overload is momentary, then choose the motor with a low rating and let the motor be overloaded for a small duration. Now coming to the power quality. The poor power quality means there are very fluctuations in voltage and frequencies. And voltage unbalance means all the three phases of the motor, they are not equally loaded. So there are unequal voltages. There are unequal voltages in three phases of motor. The voltage unbalance may occur because the transformer from where the supply is coming, all the three phases they are not equally loaded. That is just a small example. If there is a voltage unbalance of 0.3%, then current unbalance will be 0.4% and the temperature rise won't be there. But if there is a voltage unbalance of 2.3%, then the current unbalance will be 17.7% and temperature increase will be 30 degrees Celsius. So if the voltage unbalance is 5.4%, the temperature rises 40 degrees Celsius. And the winding insulation life is reduced by 1/2 for each 10 degrees Celsius increase in the operating temperature. So this is the effect of the power quality on the performance of the machine. If there is an unbalance in the supply, then it will result into the temperature increase, which will result into the lower insulation life of the motor. Now, the voltage unbalance, it should be kept within the limit of 1%. The major options are balance single phase loads equally amongst all the three phases, segregate single phase load which disturb load balance and feed them from a separate line or transformer. Then load and power factor improvement by matching the power factor capacitors. Then the minimizing the voltage drops from substation to the motor terminals. So the cable should be such, either the appropriate size of the cable should be chosen or the distribution point just to be near to the motor terminal. Now the next point is the rewinding of the motor. Now sometimes happens that in the industry more than 50% of the motors, they are the rewound motors. Now what happens with the rewinding of the motors? They reduce the motor efficiency. Now if the rewound motor has to be used, then there are certain instructions. Get the motor rewound only from the certified firm and see that the motor maintains the original motor design. And if the motor is 40 HP and greater than more than 15 years old, Then instead of rewinding, buy the new motor, replace it with the energy efficient motor, and buy the new motor if the costs are less than 50 to 65% of the rewinding cost. Sometimes there happens that we should compare the test results with the original, with the test results of the original motor. So once the motor is rewound, ask the person to perform the test in my presence, take the data sheets and compare, take the test reports and compare with the original. So the original design should not be changed after the rewound, otherwise you will not even come to know that what harm it is doing to the industry in the terms of the energy consumption. Then coming to the improving power factors, because the motors, their operating power factor is bit low. So when we improve the power factor, basically it decreases in kVA loading, it reduces the losses, and it improves the voltage regulation and the efficiency of the plant system. But when what happens when we have to start the induction motor, we go with the capacitor switching. And when we are using the capacitor bank to improve the power factor of the system, making sure that the size of the capacitor is not more than 90% of the no load kVAR of the motor. Otherwise, what will happen, that the magnetizing current will become very high. So if this condition is also undesirable. So capacitor rating should be kept up to 90% of the no load kVAR of the motor. Maintenance plays a very important role. So when you have to audit, just check how the equipment machinery is maintained. So there is a checklist to maintain the motor efficiency. First thing, inspect motors regularly for wear, dirt and dust. Check the motors for overload, underloading, whether the motor is overloading. So that complete recording can be taken, that what was the current flowing in the motor. So from then we can work out what was the percentage loading of the motor, and we can plot our own curves to find out the load pattern of the motor. Then lubricate appropriately. Lubrication should be proper. Even if there is excess lubrication, that is also harmful. It may saturate the motor insulation. Then alignment of the motor and equipment is very essential, and adequate ventilation is also required, because if the temperature increases, then the chances are there that you have to go for the rewinding of the motor because of the insulation failure. Now coming to the starting of the induction motors. Now we all know that at the starting the induction motor develops more torque than required, and that stress is transferred to the mechanical transmission system, resulting in excessive wear and premature failure of the chains, belts, gears. And at the starting there is a high inrush current flowing in the system, which is normally 6 times more than the normal current. So we can recommend the soft start of the induction motors. Basically these are the reduced voltage soft starters. They deliver a controlled release of power to the motor, so there is a smooth stepless acceleration and deceleration of the motor. Advantages of soft start are that there will be less mechanical stress, power factor will be better, lower maximum demand because there won't be inrush current at the starting. Now sometimes what happens, there are huge motors installed in the industry. So when the motors are started, say 2 or 3 motors are started together, there will be a high inrush current flowing in the system. It may happen that your maximum demand has exceeded the predefined value, so that sometimes it may ask for the penalty from the electricity utility. Then it requires a less mechanical maintenance. Now I have just taken the 2 examples. That is a soft starter. There are 2 curves, time, current versus time, then mechanical stress versus time. If we see that if we use direct online starter or start delta starters, in both the cases we get the current surges. But if we are using the soft start, there is a smooth start. The ramp is very smooth, so there is no power surge. And if we talk about the mechanical stresses, if we use direct online starters, there are mechanical surges. But with the soft starter, the surge is not there and there is a smooth start. Now coming to the major point, like we have to work out that which is the area, which is the device which has the maximum energy efficiency measures. When we say that loading of the motor, what constitutes load? Basically, load refers to the torque output and corresponding speed required. So it means torque and the speed when we talk about the load. Now there are the three types of the loads on the motor. We have a constant torque load, we have a variable torque load, and we have a constant power load. When we talk about the constant torque load, the output power varies with the speed, but torque is constant. And the common examples are conveyors, rotary kilns, constant displacement, pumps. When we talk about the variable torque loads, the torque varies with the square of the operation speed and the power varies as the cube of the speed. So all the centrifugal pumps, fans, HVAC applications, they have the variable torque loads. And this is the area where you get the maximum energy saving. Then we have a constant power loss where the torque changes inversely with the speed. The examples are machine tools, vibrating conveyors, punch presses, rock crushers, etc. Now, if we see, we have a constant power, constant torque and variable torque, and if we find out what is energy saving and the speed, we find out that the constant power loads, like what are the constant power loads, torque changes inversely with the speed. There is hardly any scope of the energy saving. So maximum saving is here, that is the variable torque. Even constant torque loads, they offer some opportunity to the energy savings. So it means the centrifugal fans, pumps, they have the maximum potential for the energy saving where we use the variable speed drives. So largest potential for energy saving is with the variable speed drives, and it finds application in variable torque application, that is centrifugal pumps and fans, where the power is in directly cube of the speed, varies as the cube of the speed. So I just give you a small example. If the motor runs at 90% speed, power consumed will be 73%. If the motor runs at 80% speed, the power consumed will be only 51%. Although constant torque loads are also suitable for the variable speed drives. Now, when we talk about that, the motor has two parameters load. One is the torque, another is the torque and the speed. The frequency of the power going into the motor will control the speed, and the voltage applied to the motor will control the torque of the motor. So this is one thing. I have not discussed the variable speed drives because main focus was on the energy audit and all. So you can see that what are the different types of loads. Then the variable torque loads, they are the areas where you can find out the maximum energy efficiency. Now last is the make use of the energy efficient motors. They are the energy efficient three-phase induction motors. These motors, they have the increasing low losses, and the efficiency is nearly 3 to 7% higher than the standard motors. There is a wide range of the ratings. These motors, they are no doubt more expensive than the standard motors, but the payback period is very less. So if we see the curve of the standard motor and high efficiency motors, we can see that the energy efficient motors, they are more efficient than the standard motors. Now, energy efficient motors, they have many more advantages. One thing is that operating costs are less, and additional benefits they have, that they have the extended warranty. They have the better tolerance to thermal stresses resulting from stalls or frequent starting. These motors, they have the ability to operate in higher ambient temperatures. Then they have the increased ability to handle overload conditions due to cooler operation, and the surface factor is 1.15. So it means they can run for 15% overload without the temperature rise. Then there are few failures due to the impaired ventilation. That is, if ventilation is not adequate, so temperature rise is basically low. So there are less chances of the failures. And they are more resistant to the abnormal operating conditions such as under voltage, over voltage, or phase unbalance, etc. So these are more benefits of the energy efficient motors. Now question arises that when you have to give the recommendation to the industry, which motors they need to be replaced. Now, energy efficient motors can be considered if there is a new installation, some new setup is set up or energy is going for the extension. Now, for all the new installations, go only for the energy efficient motors. There is no need of buying the standard motors. And when there is a major modification done to the existing facilities, then go for the energy efficient motors. And if you are buying the new equipment like air conditioner, compressors, then it should be energy efficient. And when we have to replace the failed motors, or we have to purchase the spares and all, or when rewinding has to be done, then instead of rewinding, just replace them with the energy efficient motors. Oversized motors, that is underloaded motors, they can be replaced with energy efficient motors. And sometimes the energy, they have kept a budget for the energy management program or preventive maintenance program. In those cases, the motors can be replaced as a energy efficient motors. And then you can do the calculation that if the motor is replaced, then what is the kilowatt saving, and this is the formula by which you can put the data and find out the kilowatt savings. And then there are international efficiency classes. These are the latest classes which are applicable all over the world. We have 3 classes: standard efficiency, high efficiency, and premium efficiency. IE stands for international efficiency. There is a super premium efficiency, IE4, that is the for asynchronous and synchronous motors. Now these are the audit worksheets for the electric motors, that when you go to the industry, you can calculate the, you can take the data of the motors in this format. So this is the motor load analysis, that we take the data and put the, we take the data, then we do the load analysis, we find out what is the motor loading and all. Then at the end, we are working towards the star and labeling scheme. So in the industry, the government has given many products for which the star labeling is mandatory. For some of the products, it's the voluntary. So whether it's your home or it's your industry, just go for the star rated products. And we has changed the star label. So this is the standard star label which we all have seen at our places, even at the workplaces also. All refrigerators, air conditioners now are coming with a star label. So this star labeling system has really brought a revolution in the country, because the people, whether they know anything technical about the product and all, but they at least know that it's a 3-star rated or 4-star or 5-star rating, and the people now they feel proud that okay, I have bought the refrigerator with 4-star rating, or I have bought the air conditioner with a 5-star rating. So earlier this was a star label where the stars are being mentioned. Then there is the energy efficiency is mentioned. What is energy consumption? If it's a air conditioner, then what is the energy efficiency ratio? In the new label, this thing is marked in the green color now. Now you see, as the technology is changing and all, so benchmarks are changing every year with the development of the new technologies. Now if you buy new product, you must have seen that they have mentioned that what is the period for which that star rating is applicable. Normally it's 2 years. So they have mentioned on the label that this is valid, this star rating is valid for this period to say 1st Jan 2014 to 31st December 2015. So it may happen that say you have bought a 5-star rated product today, but next year technology changes, so your 5-star rated has become 4-star rated in the next range of the products. And at the end, I would like to share that there are some energy audit of the buildings. We give some kinds of assignments to our students, like conduct energy audit of your house, institute, and find out energy savings and see if the existing equipment can be replaced by the energy efficient equipment. And then we give the exercise to our students, like to find out that if there is a product and there are star labeled, B star labeled products from 1 star to 5 star, then what will be the energy saving if comparing it with the no star rated appliance. So they work out the exercise and work out what are the energy efficiency measures. So we provide them the worksheets and all. So I have just taken one example, like at the first they have to write down what is the name of the equipment. They have in the second column, they this worksheet you can change it. You may come up with some better idea and all. I had just put because I feel that this is covering almost all the points. Then what is the rating? What is the quantity? What is the total power rating in kilowatt? Then what are the operating hours per day, power consumed per day, power consumed per month, and what are the charges per month. So we have listed some of the components that if it is lighting, they can work out whether it's incandescent bulb, fluorescent tube, CFL, what kind of light fitting is being installed in the building. So same exercise can be repeated for all the equipments. I have listed equipment against this equipment, all the parameters remain same. So due to space constraint, I just listed like air conditioners. Again, you can further segregate air conditioner, what is whether 1 ton, 1.5 ton, 2 tons, whether it's an inverter technology or something. Coolers, then what kind of a cooler, refrigerators. So any devices, you can list down the devices, or student may write down what are the additional devices. So as such, we fill the data for all the there. At the end, we total them. What was the total rating? What are the total charges per month? So this gives the first thing, give the idea to a student that what is energy consumed by the products, like what are the charges against each product. So it's not only monthly charges. You can from there you can also work out that each component is consuming how much energy in a month. And if you are using a DG sets, then we specify what is the diesel consumption and how much electricity is generated by the DG set. Then after taking all the data, this is the students, they compile the data in this format. What is the energy consumed by a device in a day? They can compile the data from the sheet also. From there itself, the calculations can be done, or they can be done in this format. So one and the same thing. So energy consumed by a device in a day, what is the power rating of the device, what is the number of operating hours, then total power consumption per day, then electricity consumed in a month, what is the unit rate of electricity by the utility, then what is the unit rate of electricity generated by a DG set. They themselves calculate, okay, what was the diesel consumed and what was the units generated by the DG. Then they calculate the electricity bill of the industry. So what is the total unit consumed by the electricity and what was the cost involved due to the operation of the DG set if it is applicable. So this is how it's a small kind of a energy audit of any building. Now this part is applicable to the industry also because they have the offices and all. So this exercise will be carried out there also. But for students, to spread the awareness amongst the students about energy efficiency, energy conservation and all, they can be given these kinds of small exercises and they can be asked to work out that what was the energy bill of the industry of the building, and then after going through them, then I can say then they can work out that if they can replace the existing technology with the energy efficient technology, then what will be the payback period, and if we replace the no labeled equipment with 1-star label or 2-star or 5-star, then what will be the energy saving. So this is one of the practical exercise which we ask our students to do. And since these all calculations, they are meant for everyone, like whether you, me, everybody, whether person is technical or non-technical, domestic sector is consuming 22% of the energy consumption. So everybody should be aware about the energy and its importance. And then the students, they are being asked to study the electricity bill because sometimes they really don't know how to read the electricity bill. But once they have to fill the data in the performer, at least they bother to go through the energy bill of their house and they see what are the rating, and some awareness comes to, okay, this was the electricity bill of the house. Otherwise the father or mother, they are paying the electricity bills, they are damn bothered that what was the bill of the industry and all. But at least these activities, they spread the awareness amongst our young engineers. So I would say the future of children, the future of our planet, it's in our hands. That's why energy matters. So every person is the right person to act. Every moment is the right moment to begin. The time to act is now. So that's all. If you have any queries, you are open to it.
Madam, when we ask for energy auditor to come to, let us say I have come from one institute and I'm asking the energy auditor to come to my institute, what details I must give to him for the auditing to be done?
First thing is not your responsibility. Auditor will ask the details from you. Auditor will ask, normally like we have prepared some standard formats. So like I give you that preliminary audit is just a walkthrough audit, and an auditor visits industry, just get familiar with the procedures. But normally what happens, sometimes we just provide the performer to the industry and we get the inputs from the industry just to work out that what time frame will be required, what time we need to spend in the industry, and how much charges we need to pay from the industry. So we just work out what volume of work is required. And if you have to get the energy audit done, then it's not your problem, it's the energy auditor to see that what he needs to get the information.
What charges are energy auditor?
It can vary from thousands to lakhs. It all depends on the amount of the work done.
Madam, the work. So manager is auditor and then
No. When the energy auditor visits you, it can be a person. Normally, the auditor is at least accompanied by one technician. Take the reading set. Now, depends on what is the size of the industry. I told in the beginning that the type of the audit depends on the what is the size of the industry and what is the requirement of the industry. So it can be a team, external auditors who are coming to audit your organization. It can be a team of the professionals. There can be one or two auditors or one or two technicians along with them, or there can be one auditor, one technician if there is a small scale industry. Now, when they visit the industry or the organization, no doubt they have to take the input data from the industry. So when we see the team is being formed, then the management depute some of the members of the industry with the external team. Now, those members may be at the position of manager, like shop floor in charge, some of the technicians of the industry, like who are the working on them, some senior persons. So all of them, they form a team. Because ultimately the external agency has to take the data from the internal members only. So their cooperation is required.
Do you have any doubts? Huh? Yeah, centers. Hello, sir. Yes, you can ask.
Ma'am, by performing the audit in industry, as stated, there will be different types of instruments for taking readings. But my question is that whether the readings provided by data loggers are.
Your question is not clear, sir. You keep your mic little far.
Hello?
Keep your mic little far and speak because it is not like echo.
Ma'am, by performing energy auditing in industry, as stated, we are using different types of instruments for taking readings as an energy audit. But my question is that whether the readings provided by data loggers are considered as effective parameters of energy audit.
Data? Yeah.
We couldn't understand the question clearly. We heard the word data logger, okay, and other things we couldn't hear properly. Yes. Keep your mic away. Tell one sir, your mic away and speak. अभी बात करो. Don't take your mic to your please don't use the mic. Keep it away and tell ask the question now. Yeah, now you ask. We can hear you.
Ma'am, whether you are getting my voice or not?
Hello? उन्होंने कुछ और आप थी छोटा सा.
So will you please repeat the question? Like You are talking about.
Right, chat में लिख दीजिए, right.
You can, sir, you can ask the question in your chat. Chat के window में, like in your chat window, please type the question. Your voice is not. We couldn't get your voice clearly.
Ma'am, data loggers readings are reliable or not?
Okay, data loggers readings are not.
Data loggers are very much reliable. Normally, if you have bought equipment with the data logger facility, it must be expensive and accurate equipment. So data loggers, you can take the readings from there only. So you got your answer?
उनको कनेक्ट करना है एक बार.
Sir, if the question, sir, can you hear me?
Ma'am, आगे उनका.
Okay, उनका reply. They understood. Okay. Okay. So now we have come to the end of the session, and I really thank the coordinators at various nodal centers and the participants here. And I hope this session would have been a very useful session for you. And now we are just breaking for the tea here, and the participants, you can have your tea. And tomorrow at sharp 10 o'clock we will be starting the next session. Okay. So the nodal centers, tomorrow sharp 10 we will start with the next session.